the food safety, but we are involved with the other certification as well, like, this kind of energy. And other factor is like none of us are coming from a engineering or physical background, right? So normally, like when you go for the ISO 50,000, the energy management, uh, like, you should have a very strong, what do you call, the analytical mindset, as well as some sort of a background, science-based background, the physical background kind of a thing. But none of us. So my background is 100% chemistry and manufacturing management, and the other two trainers are like you. So I think like this training program, apart from the knowledge we are sharing on the energy management system, we'll be sharing like, we are basically opening up the scope, new scope as well. So the both of the trainers are like, they are in the field for like long time, and then they are coming from very strong food background. Their basic degrees are food, both of them, like you all. Maybe majority of you are coming from food background, right? I yet to find out. So that is the case, right? So you expand the scope, and then let me add one more thing, because like, when we work with the Procure team about this new concept, new training program, like, the energy, uh, we discussed like, one particular project is a global company, right? Is a global company. They have like, global manufacturing factories all over the world. And the first ISO 50,000 project, like, certification achieved by, they have two companies in Sri Lanka, one of the Sri Lankan companies. And that particular project is led by the QA manager. He's also having a food background. Right. So this is like, see, this will give you like, kind of like, for you kind of a additional advantage. Say if you are apply for job in like, the industry where they have all four certificates, and then if you are not stick to the food safety, you stick to the different categories. So that will basically help you. And then this program, even though it's online, is designed in a such a way, it's not only we talk about the theory part, we are going to discuss about the practical aspect as well as like some case studies. So even my 2 hour session, we will be basically doing some case studies as well, but related to standard. And same time, the other two trainers, they will be doing a lot of case studies with you. I think like they might sometimes send you a data sheet where you can like, work on those datas, right? Okay. Now that's about the program outline and about the trainers, and then it will give like, open up new areas for you as well. Now, can I know about yourself? Like, maybe you can say like, are you coming from the food background? Do you have any background about the energy, or you are just a university student, or like, are you having engineering background? Are you involved in the 50,000? So we have about 53 members. So I would like to know at least 4 5 people. You can unmute your mic, and then you can present yourself. Like, you are a university student, or like, are you into energy, or are you want to 100% on food safety, but due to curiosity and you need to explore what is about this energy, like, what is that is your intention about the program. So can I get some feedbacks? Maybe from a few people. You can use the chat as well, because we are going to do a two-way communication. It's not only one-way communication. Otherwise, it will be very boring, right? Because I'm just looking at the screen and talking. You all not even on the cameras as well, right? So just I want to get the feedback, and then this will be the way we are doing the program, right? Like, we will be having open communication with you all. So can I get the feedbacks? You can on the mic, and like you can say, are you a student? From which discipline? Or are you from the industry members? Can I get the feedback? Because this is a kind of a sampling, right? So I would like to know about the complexity of the crowd. So then I can customize. Okay. So all right. Okay. So we have one feedback. I'm university student. I'm studying bioenergy. Uh, Santosha, like, what do you mean by bioenergy? Can you just elaborate? So is a part of your subject, or like it's the entire degree is based on bioenergy?
Uh, Good morning, sir. Actually, bioenergy is a specialization of my degree, and
Okay.
the degree is a biosystems technology. The
Biosystem
specialization
technology.
part is bioenergy. They have a
Okay.
renewable energy and biodiesel, bioethanol, and energy management systems, heat recovery system. That kind of things are including in that degree.
Excellent, 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 excellent. So the energy management is part of your subject as well as like the recovery. So like earlier we can like when organization identify their like the energy consumption, they converted into the carbon footprint and then like they you can offset, right? So right now the industry or the world doesn't accept the offsetting part, right? So you need to minimize it. So this will be very handy, right? Santosh, like we'll have a communication, right? So this will be very interesting for you as well. Thank you for your feedback. So we have Minili, recently graduated from Department of Forestry and Environment Science. Okay, so we have people from Environment Science. So the energy and everything is part of it. Uh, Graduate doing electrical and electronic. Okay, electronic and electrical engineering, okay. Facility management undergraduates, okay. Critical competent facility management. I have completed my degree in energy and environment technology, University of Shahadana. All right, so we have Nimanta. So working for Climate Fund, you are doing the audit, right, Nimanta?
Yeah,
Nimanta. So
hello.
you're doing the carbon footprint energy audit as well, right?
Yeah,
So you may be working with the next trainer, the last one, the Pushpika, I guess, for the GHG, SCA calculation and all.
no, I joined recently.
You joined recently. Okay, interesting. Right. So forest, environment, facility management. So are they like I was under the wrong impression, right? So most of you are coming from a like environment, sustainability, forestry, and then facility management background, right? All right. Okay. See, this is the importance of doing uh, right. So we have somebody, Michelle, from apparel industry under sustainability. Okay. So Michelle, are you doing like any energy audits, energy calculation and all?
Actually, at the moment, we have already started to do these energy calculations under GHG verification.
Okay.
We have started some kind of energy projects also.
All
So,
right.
for further understanding and knowledge, I have joined for this program.
All right, excellent. So, like, if you started with GHG will basically give you a kind of a outline of the total carbon footprint, right? The energy usage. But this ISO 50,000 will basically analyze it, right? And then reduction plan, everything will basically give you on this. So, because in the second, third session, like you'll be doing the case studies, right? And how to do the significant energy users, and then how we're going to go for a reduction with the case studies. Okay, interesting. So my first impression was wrong, right? Because most of you are there's nobody from food background, right? All right. Okay. Interesting. Is there anybody from food background? See, this is the importance of doing sampling, right? Like when you do the sample, you will get the clear picture. Technology, bioenergy. Yeah. So I think like now we have a crowd like who already into it. So that's easy. So let me go a little bit deeper, and then even I'll just pass this message to the two trainers as well. Okay. Now, my job is to explain about the ISO 50,000 standard. Like one thing. I'm green technology. Okay. So let me move out from the presentation, and then I just want to show the standard. Hope you can see the standard, right? Can you all see the standard?
Yes, sir.
All right. Okay. So we have somebody from beverage as well. Okay. Interesting. So we have done a lot of work in beverage sector as well. So Varna beverage, not Varna, but we have work in beverage sector as well. Okay. And then government industry also we have done a lot of work. So we can take a lot of example. So this is the standard we are referring to. I'm not going to go through the standard, but let's get back to the presentation. So you can see here, this is the second edition, right? This is the second edition. So first edition, ISO 50001, 2011. So there's no much difference in these two standard. Only thing like, there's both standard. This second edition, they actually brought up the context part. This is about very important. The context analysis part, like, the organization context, need and expectation of interested parties, all these things they actually brought up. So there are 10 elements. So first three elements, we don't need to worry. Context, leadership, planning, the support, operation, performance evaluation, improvement parts are there, right? And then these are the basic standard requirements. So now you see the standard, like say standard base. I don't know whether this is the first time you are seeing the standard. Just I will talk one sentence, right? So these are like, about the definitions about it. And then like, standard is very simple. Say element number 4, it said understand the organization and its context. The organization shall determine external and internal issues that are relevant to its purpose and that are effective ability to achieve the intended outcome of energy management and improvement of energy performance. So these are very critical stages, like, energy performance. Say, for example, right now, this statement, it need to define by the top management, right? Why? External factors. Now in Sri Lanka, there are so many external factors are affecting, because now there's a war going on. Due to this war, there will be a fuel scarcity, right? And then that scarcity actually impacting all our businesses. So now we need to take care of that part as well. So this is the critical area we need to discuss. Now what we're going to do about it, right? So those that like discussion has to be taken up by the ISO 50,000 certification body. Even not only the people who go for energy management system, everybody should talk about it. But this is the key requirement. What will happen? So whether you are going for alternative fuel or whether do you have a backup plan. So all these things we need to discuss. And then same time, once you complete, this is the tricky part, energy performance, right? Say, for example, say you are certified for first year, you are showing like, you will be doing some energy improvement, right? Performance improvement, and you get the certificate, right? And then next year, after 1 year, certification body will come for the audit, and then they will ask, what are the energy performance improvement you have for this particular year? If you don't have that energy performance, your certificate will be like hold until you show some energy performance improvement. So this is a very tricky certification, because always you need to show the performance. That's the challenging part, right? That's the challenging part, right? So none of the other ISO standard doesn't go into this detail, right? So let me go back to my presentation, right? So just want to show the standard and the outlook of the standard, right? Let me go to the presentation. Now, I believe like you have a good understanding about the standard. Now, tell me like, the presentation, can you see the presentation now? Is it okay?
Yeah.
All right. Okay. Thank you. Let's move on. So this is the 2018 version, second edition. So in this program, like what we try to do is like, within my 2 hours, I try to cover introduction, the why is matters, key benefits, and then requirement and implementation plan, right? And then basically introduction, it's a alarming fact for today in 21st century. Billions of people lack of access to most basic energy service, right? So even now we are also part of it, because due to this war situation. See, even previously, there are certain set of people, they are not like, getting a basic energy services. But in Sri Lanka, we were okay at that time, because we had two sort of energy mainly, like, the hydro as well as the fossil. Apart from, we had a biomass as well, and then solar. So there are different energy sources, but we are heavily dependent on hydro and fossil fuel, right? But right now, we have a situation where we don't have, there's a lack of, like, we are facing the drought situation. So we are having a hydro situation. Hydro is a kind of a concern right now. And then due to the war situation, we are having a fossil fuel, right? So now also, like, entire world is suffering because of this war. And effective management energy usage is crucial in confronting the challenges of climate change and resource depletion in future. So this is a depletion resource. And then, of course, climate change, because most of the energy other than the biomass, right, it contribute to a climate, carbon footprint increase. So all other energy sources, solar and, biomass, are mainly the fossil fuel. It emit a lot of carbon dioxide, or, the greenhouse gases. So this will impact for the climate change. And then right now we have no idea what happened to the climate due to this war situation. The amount of emission, right? We have no idea right now. I don't think anybody has done the calculation yet, right? But the previous, we use the carbon fossil fuels and everything, and then we know, like, okay, we are in a very bad situation right now, right? So 50,000 standard as an organization to demonstrate in a efficient energy management system. It's not just a management system; it's an efficient energy management system, right? This allow enhanced to commitment of organization to improve energy performance. So automatically, this will basically improve the energy performance, right? So this is the key factor, right? And then there's a question, why energy matters. So one is raising energy cost, and second thing, scarcity of the energy, right? Then environmental concern and regulation, like, we when you use the boilers, biomass and all, we have to adhere to this, the environmental guideline, like SOx, NOx, and all carbon monoxide. So there are environmental guidelines which is given by the Central Environment Authority, right? So those things are available, right? And then same time, sometimes, like, when you go for the open market, or especially the international market, now they started to ask question, like, what is the carbon footprint, right? GHG for this particular product, right? So it goes beyond your GHG calculation. It goes to, like, life cycle assessment as well, right? So even in Sri Lanka, like, very few people can do this life cycle assessment, because you need different kind of a software, right? So then there will be a market advantage. And then the buyers, they prefer to work with the organizations who are more sustainable, right? Like, they care about the environment, care about the people, right? So that concept's already there. And then this is part of the social responsibility in the most of the organization, especially in the garment industry. Now it's a part of the key requirement, as well as, like, some industries, even in Sri Lanka. Now, when you publish, like, your annual reports, to the annual report, you need to publish all this information, right? GHG information and all. So it has to be, like, it's not sometimes like verification data, but it has to publish those information. So now these things are actually coming up, right? And then on top of that, there's a social sustainability goal, like, US sustainable goals are there. So there are three goals, right, you can cover with ISO 50,000. One is affordable clean energy, the goal number 7. I believe, like, the crowd, like, about these sustainable goals, right? So the goal 7, affordable and clean energy. And then goal 12, responsible consumption and production, right? And then goal 13, climate action. You can automatically cover all these requirements, right? And then these are the benefit. One is cost saving. Say, for example, when you do a calculation, carbon footprint, or like whatever, so it gives, like, overall picture. But when you do a energy calculation, so depend on the product complexity, you will do a calculation saying, okay, look, my energy kilowatt hours or joule consumption per tonnage, right? Say, for example, now garment field, you can do a calculation per unit. What is my kilowatt hours, or maybe joule? So if you are using a different type of energy source, like, say, for example, you use electricity, you use hydro, whatever, and then you use biomass. Maybe you will say you have a dye house, and then, like, maybe you use a solar. So, like, the units will be different. So you convert everything into a joule, right? Or maybe kilojoule. So you can say, okay, this is my output. Or maybe if you're coming from a hotel industry, you can do like, kind of ratio, like, per plate, per guest night. So always you give a kind of a ratio. So then automatically once you analyze like, okay, per unit, this is my energy consumption. Or per ton, this is my energy consumption. Then you can have a reduction plan, right? So depend on your, like, the technology, depend on your, the organization, you can have a reduction plan. So it automatically cost saving, because if you can cut down the cost, right? So it will give a benefit for your organization, and it should reflect in your finance report, right? Say, for example, you use this X amount of diesel, and then you cut down by 5%, right? So that 5% should reflect your energy bill or whatever, right? So that has to be there. And then, of course, enhancing reputation. It will be part of the risk management. Right now, I think, like, in industry, see, most of the discussion are pretty much based on the energy. Even we are being a consultancy firm, we'll be using energy mainly for the transportation, because we have a big team. Our team has to travel all over, and then transportation is a critical factor. One is like, one is the control factor, and one is the cost factors. So anyway, we are using, like, club, like, we basically club that entire team. Like, when we do the planning, that was already there. When you do the planning, like, we plan, like, one direction, like there will be one or two or maybe three consultants will be go in a one same vehicle, not three people go by the three different vehicles. So that was there. But right now, this cost factor and the scarcity, and even we have calculated our carbon footprint as well in our organization. So we calculated based on the kilometers and the number of project, right? So that's the ratio we have given. So based on that, what we did was, like, we basically, like, cover. Now we have to be put more effort on that. So like, how we are going to cover the continue the same effort, same customer satisfaction, but has to be more cost effective. So this is very critical part, right? It's a part of risk management, and then continuous improvement. So this is a very key requirement in energy management system, because continuous improvement has to be there in the standard. And then, of course, if you cut down the energy usage, right? If you cut down the energy usage, of course, it will reduce the environmental impact of the organization. So these are the key benefits we are looking at. Now, so this standard talk about the context, leadership and commitment, planning, support, implementation and operation, performance evaluation, and the continuous improvement. So this is the basic requirement. I show you, right, even using the standard, I basically show you, like, this is the initial requirement. So you have a standard, and then it's talk about, at the context, you need to study your internal and external factors, right? So external factors right now it's pretty open. The war, the fuel scarcity, and even in Sri Lanka, like, now we are facing the heat, the drought. So those things we started to discuss, right? So those things we are basically talking about. And internal factors, type of machine, people attitude. So those things we can discuss. Now let's go into the standard, more into standard. Now, when you go for a standard ISO 50,000, it's talk about, like, PDCA. So any
ඇහුන්නේ මොකද ආයි කියන්නේ?
මං කියප එක දැනුන්නේ නැත්te වෙන එකක්ද?
කවුද?
මම trainer.
අපෝ කොහෙන්ද දන්නේ එච්චර අරන් තියෙන්නේ?
මොනවද අරන් තියෙන්නේ? එනර්ජිද මොනවද අරන් තියෙන්නේ?
එවන්න බෑන්. මං ගණන් හදලා බලන්න මාස ටිකේ ඔක්කොම ටිකත් එක්ක එවන්න බෑන්.
පෙට්‍රල්ද ලීටර්ද කොස්ට් එක බලන්නේ?
මොකද?
පෙට්‍රල්ද ලීටර්ද බලන්නේ ඔක්කොම එවන්න කිව්වේ. හෂි මොනවද ගණන් හදනවා?
යපේ එහෙමනම් මිනිහෙ.
කවුද හෂි?
යකෝ දීලා තියෙන තමන්ගේ ගෑණිට වෙන හොර ගෑණියට නෙවෙයි හොඳේ.
හෂි ඔයාගේ ෆෝන් මයික් එක මියුට් කරලා නැහැ. හෂි
ආයේ මාස
කුමාරතුංග.
දෙකකට මම ඔයාගේ වැඩ ටික කරලා දීලා නැහැ. ඔයා කියනකොට අතට දුවලා මෙතනට දුවලා
හෂි ඔයාගේ මයික් එක on. හෂ් නේද? හෂි නේද? Right. I basically mute the mic, right? Guys, just be professional, right? Like, all of you are coming from a very decent background. So when you participate for this kind of program, you need to have that decency, right? Like, if you think program is not good enough, maybe you can leave. Otherwise, you should not disturb the others, right? You have to be very careful. Yeah. So all of you are coming from very decent universities, and all of you are doing very technical degrees. Yeah. So let's move on. Right. If you have any question, no problem. You can stop me and ask question. Right. Okay. So any ISO 50,000 standard or any ISO standard, sorry, any ISO standard, right? It talk about PDCA. You call plan, do, check, that, right? So all even ISO 9000, 14,000 food safety standard, any standard with PDCA. Even this training program, you do with the PDCA, right? Plan, do, check, that. So you plan the program. Now I'm doing the program. Checking can be like evaluate after exam or whatever, or maybe how you implement this the ISO 50,000, or maybe then you can take action, right? So in planning stage, there are few words like conduct the energy review and establish the baseline energy performance indicator. So there are new areas. So what do you mean by energy review? What do you mean by baseline? What do you mean by energy performance indicators? Objective, target, action plan necessary to deliver results will be improve energy performance in according to the organization energy policy. Say now, energy review. See, now like I think like we have people who coming from the same background. Say, what do you mean by energy review is like you need to understand. I think like Mr. Hashan will do the detailed calculation and everything, right? But let me give some brief understanding about the energy review. So, energy review can be like you understand what are the sources, right? What are the energy sources? Like, say, for example, if it is a garment factory or if it is a beverage factory. So, garment factory, you basically get like, depend. If it is a cut and sewing, basically you use the electricity, right? So, we have a friend from garment factory, right? What is the source of energy you are using?
Electricity. Electricity.
Measure electricity, right?
Yes.
No steam, no biomass, nothing, right? You don't have a dye house, nothing.
No, currently we're using a solar power,
Okay.
but basically CB power.
CB power, right? So you are using a CB and a solar. So you
Yes.
have two energy sources. One is electricity, other one is solar. And we have a friend from beverage industry. So what are the source of energy you are using? Tanuj, what are the energy source you are using? Tanuj is not there, right? Right. Tanuj is there. Tanuj, what are the energy source you are using? Think like as far as I know, like beverage industry use the CB electricity. Maybe they might have a solar, and then they use biomass, right? Or maybe a fossil fuel for the boiler. Tanuj Vikramasinghe, you are there, right? So these type of like energy you are using. So we'll take these two case studies, right? Like and then if you understand, Michelle, can you tell me like what is the most like significant energy users? Say electricity, what is the most significant energy users? Like in garment industry, what are the machines or what are the department will use more significant energy? If you have some idea about it.
Yeah. Yeah. In apparel, it's almost sewing machines,
Okay,
but sometimes it's depends with compression machines also.
agreed.
So mainly in our company, it's almost sewing machines plus
Right.
compression machines.
Compressor. Okay, so
Yeah.
I agree with you. So say you have about like say 2,000 machines. So there will be 2,000 motors are there, all machines, right? And then you have a compressor because pneumatic energy is there. So you're using a compressor as well.
Yes.
And then on top of that, Michelle, one more thing. Is your facility AC or like it's under room temperature?
Under room temperature.
Under room temperature, but you have a fans, right? Fans and no, maybe you have
Exhaust
a
fans. Exhaust fans are there, but
uh,
uh, No, actually, we can say it's no air conditioned system. It's
No,
under
no air
normal.
condition system.
Yes,
Yeah,
yes.
sometimes we might have a challenge. We think like, okay, significant energy users is the pneumatic compressor as well as the motors. But then when you started to do the data analysis, you realize like, your AC will consume lot. And same
Exactly.
time, if you have a exhaust fan, right? Because sometimes exhaust fan motor capacity is very high, right? Your factory is running 24/7 or like
No, no,
only
it's day shift.
only day shift. So we
Yeah.
we found out like when you do this energy review, sometimes you will get a surprises because you think my most of the energy consumptions are based on our gut feeling. We think like, okay, it can be the pneumatic compressor as well as the machines. But then you realize you have an exhaust fan with high capacity motors, and this is run like almost like 15 hours, 10 hours plus, right? Then when you calculate kilowatt hours, that consume lot, right? So that automatically become a significant, right? Because you need that, like you can't cut down and say, okay, look, there's a high energy cost, like let's stop all the exhaust fan, right? So you can't do that because you have to maintain the thermal comfort of the people as well. Because see, this is a balancing act, right? You can't, like, if you have a AC and all, like you can minimize the AC, like temperature. I'm like, you cut down, say, okay, let's maintain at 25. That's the standard, right? But you can't say no AC, right? So maybe I mean, like, then maybe it may reduce your productivity as well. So it's a decision, like conscious decision has to be made by the management. Right now, the energy review is initially you do a detailed study about your total energy and the energy consumption. So then energy review will give a kind of a good picture about your organization energy, like usage, which department, which pattern. Say for example, now we take garment factory example, and then you said like pneumatic, the compressor energy is very much, right? So, okay, that is the most significant part apart from the motors machine. And then you realize, okay, is entire, like is there no leakage, the pneumatic energy. Say for like during the shutdown period, if you hear the noise of noise, then like there are leakage. Misha, can you assure like there's no leakage?
Actually, currently under energy improvement projects and
Mm.
from our engineering department, they are considering about these leakages as well. And on time compressed air supply for the machines without any leakages. So currently we following those kind of leakages as well.
Yes, this is a crucial, right? Because if there's a leakage, your compressor will automatically running, right? So that means there's an energy consumption. See, we have done one particular project. That is not the garment factory. Actually, that is the primary packaging, printing and like packaging, extruding and like the polythene bags factory is a like medium scale factory. About like maybe 200 people are there. So what we did was like that when we do the energy consumption, like you said, like the significant energy goes to the machines and the pneumatic, the compressor. And then when we analyze the pressure at the beginning and the pressure at the end are two different, right? So there's a leakage. So I'm like, we identify a project. I'm like, for me, it's easy to say, but when you started to work on this kind of project, it's consumed a lot of like time, analysis, and kind of investment as well. But you can cut down because you can calculate your ROI, return of investment, right? So the energy leakage, that you can plan it out. So this energy review, like this is the key part of the standard. And even when we started to work on the consultancy project, bulk of our time, like 50+% goes to energy review, right? So sometimes if you do a theoretical calculation and the final figures are not matching each other, so then you have to do adjustment, right? And then same time, some organization they have a sub meters, but some organization they don't have a sub meters, right? So only like entire thing depend on the main meter. So you can't sometimes you can't identify the like accurate energy data. So then if you come across that kind of a situation, so what you do is like basically you ask to install sub meters, calibrated sub meters, right? Then you start work on that. And the baseline is actually you identify the representative baseline. Say for example, now what we are going through in Sri Lanka, because you have a diesel and oil scarcity, you might use alternative. So this is not a normal curve, right? So you need to identify the normal curve, like, maybe 12 months, and you study your energy consumption data, energy review, everything, and then you identify this is my baseline. So maybe 2026 is not going to be a baseline year for any industry. Maybe 2025, 2024 can be a baseline year, right? Then against baseline year, you try to see what are the things you can go for an improvement. Like, and then you need to cover all the patterns. Like, say, for example, now even garment, even beverage, right? So maybe some others are industries, but I know like there are two people from these two industries. Now you're during this time, you are going for a peak production. Is it? Are you going for a peak production right now?
Yes.
Yeah, because you want to give holidays for the employees, and then for the beverage industry, they are like, they are getting ready for the season, right? So the February, March will be like, the peak, and then April will be like kind of a dead. Then again, you are starting again from May onwards, right? So this all pattern has to be covered, right? All pattern has to be covered when you do the baseline. So next session, you will cover everything. So then once you identify, you can identify the indicators. Like, say, for example, garment industry, per tonnage or per unit, what is the kilowatt hours? Or maybe a ton of beverage, carbonated beverage. Now, you might have a different question. See, beverage industries, they manufacture water, they manufacture carbonated drinks. So the consumption of energy is different, right? Manufacturing of energy, the manufacturing of water, it will be like just filling. But manufacturing of beverage, it can be different because you need to extract carbon dioxide, right? And then you need to like, mixing and everything has to be there. So the usage of energy will be different. So we need to consider everything, and then you need to develop your indicators like, KPI, key performance indicators. We are talking about energy performance indicators. Then we need to set objectives and target, and then we need to have action plan. How to reduce this energy? Now, say for example, in garment factory, you identify, okay, one of the my significant energy is compressor, pneumatic energy. Okay, can we cut down by 5%? So initially you need to add, like, do the calculation and say, okay, my energy leak is this, or maybe giving you like, kind of improvement plan, or maybe you identify wattage for machine motor is this, or maybe can I reduce the motor capacity? Right? Sometimes when you do like, engineering people, they might replace with different kind of motors. So you can have like, a common type of machine, and then you identify like, different type of machine, like they consume more energy. So when you purchase, you can go for like, less energy consuming motors, right? So those things comes in the energy planning, and then doing means like, you identify the action plan, you conduct it, and then checking means you need to check energy, and then like, if you do an energy audit, maybe with the expert, walk through audit, and then maybe with the equipment you can do energy audit, and then you can identify like, the improvement points. Say for example, if you have a the compressor, now now efficiency of the compressor, we go by the given what is given in the manufacturer, right? Maybe your compressor is very old, right? Maybe like 10, 15 years old, and then your the compressor efficiency is not at that level. So maybe energy audit will give that indicator, right? So then maybe like if you are struggling to take a decision whether to go for a new investment or not, maybe energy audit will give you a kind of a full detail, like, look, you are supposed to have a 85% efficiency, but your compressor is giving now only 55%. You are wasting, right? Maybe motor. We are going by the power rated given by the manufacturer, right? But like, you can improve those things. So energy performance improvements has to be there. So this is the basic structure we are using from PDCA. So now you can see this standard is pretty much technical, right? This standard is pretty much technical. And then this standard goes with a lot of data. See, imagine, like, a lot of like, environment and people are there. So you can visually observe if you do a occupation health and safety. What are the machines having like, abnormal sound? What are the machines are running without the guards? Right? Maybe people are not wearing proper personal protective equipment. You can visually check all this stuff. But if you check the energy, I mean, like very rarely things you can see. If you see AC leak, door open, like nobody's there, fan is on. So only few things you can check. But imagine in a garment factory, if you like check few fans, few ACs, but your like the office environment energy consumption is maybe 5% or maybe less than 5%. Right? So you're not going to save anything, right? It doesn't impact anything, but your 95% goes into some other areas, even in the beverage factory or any factory, right? So then you need to identify, you need to develop action plan focusing on that particular area, right? Now, let's move on. So when you do energy planning, so this is the basic structure, right? So you have an energy policy, you have energy planning, right? So you do a implementation and operation. So as per your planning, you do a implementation. Say, okay, now I'll take one example from Misha's gave right now. Okay, cut down my energy losses due to a leakage. So you implement different plan. So you identify, okay, within 3 months, I'm going to cut down all the energy leakage. So you do that. And then you do the checking, right? So then you identify the monitoring, measuring, analysis. You do that part. And then you identify corrective and preventive action. And then you conduct the internal audit, management review, and then continuous improve. Cycle goes again, right? So this cycle goes again. So start with the energy policy, right? Now let me move on. So when somebody wants to set the implementation of energy, maybe like one outcome from this training program would be like you might try to implement energy management system in your organization, or maybe when you get into a new position, you might start to work in. First thing, you need to get the commitment from top management. If the top management is not committed, don't go for this standard, because initially you might need to do some investment. Say, for example, I took one example. Say you have a huge factory, you have a different areas. You have a sewing, you have a dye house, you have warehouse, and then you have R&D, and you have a different section, right? But then, and only 1 meter is there, right? So first you need to invest, like, okay, I need to have a sub meters. Otherwise, your calculation will be very wrong, and then you need to spend a lot of time. But then again, the accuracy, there's a question. So you need to have a sub meters. And one more thing. See, if you want to get ISO 9000 certificate, right? Normally, right, ISO 9001, right? Normally, within 3 to 6 month data would be enough, right? Like if you have a, say, for example, now I want to get ISO 9000 for our company. Uh, Maybe within 3 months time, I should be able to get certificate. But imagine if you want to get ISO 50,000 watt, how many months data you require? What do you think? How many months data you require? Now, based on this understanding, tell me. If you want, like, now after this program, you decided, okay, let me get ISO 50,000 for our organization. How many months data you require? Nimanda, what do you think? How many months data? So Nimanda is coming from certification background. We'll ask from him. So Nimanda, what do you think? No, 12 months,
Hello.
not 6 months. Yeah, Nimanda.
So I can't hear whatever.
Yeah, 12 months. Hashi is quite right. Nimanda, you need, if you're going
So
for
what
50,000,
are
you
you
need,
asking for?
sorry?
What are you asking for?
I just asked, like, if you want to go for a 50,000 certificate, like, how many months data you required?
Currently we are doing 14,064 certification for greenhouse gas verification. We are currently requesting 12 months data.
12-month data, right? Same with 50,000. So less than 12 months, you are not going to give a certificate, right, Nimanda?
Yeah, we are
Yeah,
considering their financial year or calendar year period.
yes, you
Inventory
need that
period.
data, right? You need that data.
Yeah.
Without that, you can't give a certificate. Same with energy, right? Same with energy. So you need 12 months data. So if you decided now, of course, you need to have, like, at least 12 months data to get this certificate done, right? So this is the challenging part, right? You can't just overnight you can't get this certificate. So top management commitment, and then they should understand this concept as well. And then of course energy review has to be done. It has to be very thorough because auditors will go through each and every detail. And once you give a commitment, say for the top management, I'm going to cut down 5% of your energy, the electricity bill. So then finance team will evaluate that, whether you cut down the 5%, right? So that is a very important part. And then setting objective. So you need to develop implement action plan, and then you have to monitor and measurements. And then of course, employees, especially people who are in the significant energy users, right, has to involve with this, right? The people who are in the significant energy area, say for example, compressor, engineering department, or maybe machine operators. So you might say, okay, when you go for a lunch, turn off the machine and go, right? Depend on the machine type, right? So those people, or maybe boiler operators, right? So they should know about the energy management, not only the top management part. And then, of course, like all the other standard, we need to have a documented record, and then internal audit has to be there, and then management review. But the top part, up to six, right? Commitment of leadership, energy reviews, setting objectives, implementation plan, monitoring and measurements, employee engagement. This is the key for ISO 50000. Right. And then leadership commitment. So top management demonstrate commitment, right? And then the provision of resources. This is very important because sometimes to gain some energy efficiency, you might need to invest. Say my first example is the submeters. Or maybe when you're purchasing a machine, sometimes like some organization when they want to purchase the machine, machine purchasing is done through the top management and the procurement department. But if you are going to go for ISO 50000, technical person has to involve with that. So then he will basically say, okay, look, this machine has this kind of energy saving potential, even though this is expensive. Now I'll take one example, uh, like you know, say the AC with the inverters and without inverters, right? So without inverter, it is a cost effective. The price is low. So the purchasing might say, okay, look, this is a low cost. Let's go for this. But then the engineering team, the person with the background will say, okay, look, even though this is a cost effective, your return of investment and then energy saving potential is very much if you go for in inverter time, and you are getting this amount of saving. So that dialogue has to be there. That's a requirement of the standard, right? So maybe you can integrate your energy management system, and then this is the energy planning program, right? So you need to study. You can see we are spending like a lot of time, even Stanley is spending a lot of time on the energy management, energy planning. So in a past and present energy users. So of course you need to have at least 12-month data. So depend on the source of energy, right? Now, one more thing I forgot to ask. In garment factories, so Varna team is not giving feedback, the beverage. So now, Michelle, I'm taking you as example. So you are having additional benefit as well. Michelle, do you have a canteen which they cook? In garment industry, Michelle, do you have a canteen which they cook
Yes.
food for the staff?
Yes.
You do that, right?
Yes.
So what is the energy source they use? LPG? Is it LPG? Or yeah, I think like it will be LPG, right? So that again within your premises, right? And then you are serving food for your staff. So that also we need to consider under energy, right? So not only the electricity, not only the solar, we need to consider the LPG usage. That's part of energy, right? So that is key thing. So and then past present energy uses and relevant variables affecting significant energy uses. Now what is this? Relevant variables. What do you mean by relevant variables? Say now your factory is having a AC, right? Say your entire factory facility is having a AC, or maybe your office is AC environment. Now what is the situation nowadays compared to rainy days? Now what is the situation? What is the situation? Now, like, everybody wants AC and like, you try to reduce as much as possible, right? So that's the affecting factor is your surrounding temperature. If you are using a biomass, right, the biomass moisture level will be a big impact. Or maybe if you're using a fuel, right, for the boiler or anything, the fuel quality, right, flash point, it can create those kind of a situation, right? So this is very critical. This is very critical, right? So these factors we need to study, or maybe people, right? So we need to study not only the data, relevant variables affecting significant energy uses. Now, compressor, I told you, like, the compressor type, maybe air quality. So all these things, it matters. So we need to study those factors as well. Like, uh, we don't go into kind of a, like, uncertainty calculation, but we need to at least have an understanding about this. But right now this standard doesn't go into the uncertainty calculation, right? So now I'm very freely talking because I know like all of you are coming from a heavily technical background, right? We don't need to go into that uncertainty calculation, but we can identify the significant relevant factors. So depend on the energy source. And then say, for example, now garment factory, one of the energy sources is LPG. So LPG uses what are the factors? Variable factors, right? So we need to study that part, right? So you identify the total energy and then you do energy review. So analyze energy use and consumption energy review aspect register. You identify energy review, right? What sort of energy goes into this particular area, particular machine, and then you identify you develop your own criteria. Maybe quantity, maybe impact to the environment, and maybe potential for energy saving capacity. So you define all your criteria, then you identify the energy usage, and then based on your identify, like your ISO 14000 aspect impact evaluation, you develop this, and then you come up with the significant energy usage. So you identify this areas are my significant, then your 100% focus will be on that area, and then all your action plan based on that area, right? So then of course you identify the opportunity for improvement of the energy performance. So this is the second part, and then once you do this, then you plan your output energy baseline and energy planning indicators and objectives and action plan. So this will be the total outcome of your energy planning process, right? So this will be the total outcome of your energy planning process. Now, there are some general requirements. So organizations shall establish, document, implement, maintain, and improve energy management system according with the requirement of the standard. Define and document scope and boundary of energy management system. Say, for example, if it is a garment factory, now we miss one point, right? Within your boundary, what are the energy sources? Say electricity, solar, and then you have a canteen, you say LPG gas. So you can say garment manufacturing using this sort of energy, and then support service using this service. So you have, like, you identify, and then if of course, if you have a transport or if you have a backup generator, I believe you have that, right? Then backup generator might be using a diesel, right? If you have a transportation distribution part, then again you might be using a lorry or anything, right? Or maybe if you're having a company owned vehicles, right, you need to consider. But I think like our friend is there, he's specialized in GHG, right? So don't don't uh, uh, don't think of the scope 1, 2, 3, right? So we don't go into that level, right? We don't go into that level. We are not measuring scope 1, 2, 3 kind of a thing, but we are checking the boundaries, right? We just check the boundaries, everything. Nimata, you got my point, right? So we don't go into that 1, 2, 3 boundaries, but we are checking this the within the facility, right? So if it is company owned vehicle, right, and determine how we'll meet the requirement of energy management system. Now, this is very crucial because this scope will appear in your certificate. Now, I have a case study. Now you can use, like, can you, like, you can develop a scope of boundary for energy management system, right? Maybe if you do, if you're not working in industry, maybe think of your university, right? Maybe think of your university, or if you are not that familiar with your university, maybe think of your home and develop a boundary, right? Now you're going to develop a boundary for energy management system. Now you're going for a certification. So this is the boundary you're going to discuss. Say, I'll take one example, garment factory. So garment factory scope is we are cut sewing of garment product using the solar, using the electricity from CB. Uh, those are the energy sources, and support service by canteen operation using by LPG gas. So that is the boundary, right? So then you have, and then of course there will be a backup service by generator using diesel and a transportation using diesel. So this will be your scope. Can you define a scope? I'll give 2 minutes because we don't have much time. I'll give 2 minutes, and then you you can put it into the chat on this requirement, or maybe I'll give my WhatsApp number. You can put it to WhatsApp as well. Right, guys. Shall we take 2 minutes? Maybe you can use the chat, and maybe or you can use WhatsApp as well. Right, can we do that? Now it's 5, 10, 5. Can we do it by 10:07? You can use the chat straight away. You are going to identify the scope. So if you are coming from industry, identify the scope for your industry. And then if you are coming from a university background, just identify the energy scope for your university. And if you can't recall about your university, maybe you can type the scope about your maybe your home. Yeah, let's get few more. So you have 2 minutes, guys. Come on. Guys, so is it difficult? I'm not getting anything right now. So 1 minute is gone. Tim, can I get the feedback? So what is the scope? Very simple. What you do at under energy management system. Yeah, I'm starting to get the feedback. Let's see. Energy scopes. Energy scopes are electricity, diesel, and energy boundary, lecture hall, administration building, lab, library, workshop, canteen. Okay. Electricity, diesel, energy source. Santosh, one thing. What about canteen? What is the energy source? I'm pretty okay with this, right? So the scope. You need to mention what you do at university. So university basically, you said okay, provision of the degrees or whatever, right? So that has to be there. So that is the scope of the industry. It's like garment manufacturing. So you basically the degree conducting of degree programs, whatever, and then we say okay, we'll be using electricity, diesel, solar, and then lab, and then canteen. In canteen, they might use a different, right? What about the LPG? What about the LPG? For the canteen, you might consider the LPG as well, right? So you need to do full understanding about the source energy sources, right? So anything else? Can I get one more feedback? So we got Santosh. Thank you very much. We got a feedback about the university. So this is very important. You can improve giving a scope of your university. What do you do? What university's purpose? Say, purpose of the university is provision of undergrads or postgraduate degree program. So if you can do that, then it's perfect. And then consider the LPG part as well. Right, Santosh, thank you. Any, can I get one more feedback? Can I get one more feedback? Okay, I got a feedback. Scope of the is the foam product manufacturing system need energy with factory. Okay, so this yeah, see, I got a feedback. Cope with the foam product manufacturing. So define what you mean by products, right? Define what you mean by product. So it can be garment can be product, the beverage can be product, soap can be product, the bottle can be product. So define, say this is good, right? So you say say garment manufacturing system needed energy. So define what do you mean by energy. So is it the solar? Is it like diesel? Is it CB energy, electricity? So define both. You got it? Right. Okay. So I think all are quite okay with the scope because this will be a first thing we need to understand, right? So the people when auditors goes for ISO 50 certification, they will ask first thing, what is the scope? And then they try to defend the scope as well, right? So this is the first part. And then management responsibilities, they are top management. So under top management shall demonstrate its commitment to support energy management system, continually improve its effectiveness by, so there are defining and then appointing management representative, and then resource, including human resource, specialized skills, technological and financial resource. So I highlight this part mainly because sometimes you might need to get a electrical engineer to understand the where you are right now, or maybe you need to get in done the energy audit, right, to understand the efficiency of your machine, because efficiency you can't understand using the energy reviews, right? Because energy reviews always match with your data, but efficiency we don't know. So that part we might need to get. So that basically a top management responsibility, right? And then you need to have a management representative who is basically in charge of this project, right? Energy management system, right? He's actually in charge of this. Got a feedback. In food laboratory, energy scope, electricity, diesel, boundaries, equipment, laboratory building, maintenance. Yeah. In food laboratory, energy. Yeah. If you are running a laboratory, electricity, diesel, if you have a Jenny is there, equipment, laboratory, boundary. Yeah. Agreed. Right. So the top management part, you nominate a management representative who's having a correct qualification. Right. I told you, not only the technical people from a technical background, like one of our key project. the entire management representative is done by a food graduate, right? But he did a wonderful, but he has a analytical thinking, and he knows about these numbers. And I believe like you will be exposed to these numbers in a second session, right? So his basic job is to report to the top management, energy management system, and then make sure like, everybody knows about energy management system. So if you have become a, like, a management representative, it's a very valuable position. And then like, you need to learn how to manage with the data. So that is most important part. And then of course you need to develop energy policy. Now I'm going to give you a task, right? So the words are there in red color, right? Has to be stay in a policy. The energy policy shall state the organization commitment to achieve energy performance improvement. Top management shall define the energy policy and ensure it appropriate to the nature and scale of the organization energy use and consumption, include commitment to continual improvement in energy performance, include commitment to ensure the availability of information and its necessary resource to achieve objective and targets, include commitment to comply with the applicable legal requirement and other requirement to which the organization subscribe subject related to the energy use and consumption and efficiency, right? Provide the framework for setting and review energy objectives and target, support the purchase of energy efficient product and service, design for energy performance improvement, a document that communicate to all levels, regular review and update as necessary. So this is the key document. See, my Halcyon energy policy might be different to Procul, and then the garment factory energy policy will be different to ours. Or maybe beverage factory energy policy will be different, right? So you can have your energy policy, but once the standard, if you want to go for 50,000 standard, when you said include, right, this word has to be there. Right now, I'm going to give a small task. I'll keep as it is. This is a requirement by the standard. I give 5 minutes, right? 10, 15. I give 5 minutes. Can you develop the energy policy? See, the whole purpose of this program, like, we develop this program. After end of the day, you are not just listening to the lecture, right? You are capable of implementing ISO 50000 standard for certain extent. So that's why like we do a lot of case studies. Otherwise, if you can like, turn on and like, listen to this, but the whole purpose is a workshop, right? So I want you to involve with that. And then like, end of the day, you are pretty much like, covered the entire subject, and not only like, listening, but you know how to implement it. So take 5 minutes, run through this, try type like, a policy, like, that's why I give my WhatsApp number. Maybe you can write it down, take a picture, you can send it, right? You can use the WhatsApp chat as well. So we'll take 5 minutes. Now 1 minute is already gone. So because I need to finish within timeline. So just 4 minutes are there. So try to develop an energy policy using this requirement. Can you please do that? Yeah. If you have any question, you can ask now. Team, if you want any question, if you have any doubts, like, you can ask from me now. I believe that we are working on the the energy policy as well. Team, 1 more minute to go. I didn't get anything. Can I get the one feedback? So 10:20. Can I get the one feedback, team? Is there anyone who's working on this? Maybe you can say, like, I'm working on this. Is there anyone who's working on this? The policy? Is it too much for you within 5 minutes develop a policy? Sometimes organization will take years, maybe 1 month to develop policy, right? But is it too much? I mean, like, just sample. If somebody can publish this, is there anyone who will try this? Okay, so let me move on. Like, if you have done, like, just share with me. I will give you the feedback. See, now when you develop an energy policy, you can develop the way you want, but this red color words has to be there if you go for a certification. So commitment to continuous improvement, commitment to ensure availability of the information part, comply with applicable legal requirement has to be there. Now, since, like, you have a bulk of the people from industry, in Sri Lanka, do you have a legal requirement related to energy? Do we have a legal requirement to energy usage? So most of you are coming from a degree, the environment sustainable background, right? Now my question is, any legal requirement related to energy usage? Yes, I got a feedback, right? The Ham said, like, no. So others are agreed, right? So I'm no, not for the energy product or anything, right? Like, LED, CFL, you have a requirement, but energy usage, Sri Lanka, we don't have anything. Dham, I'm agree with you, right? So, well, spot on, like, no legal requirement. So, but as per the standard requirement, there are countries, they already have a legal requirement, right? Usage, they will give a kind of like limitation, right? Maybe in future we might, right? I don't know. Maybe in future we might, right? So this one area. So we need to worry about the legal requirement. But of course, we have to say if there's any legal requirement, we will be adhering to that. And then this is the energy planning process. So you'll be go into detail. So we need to have a documented energy planning process. So energy planning and improvement energy performance. Energy planning shall review the organization activity, affect energy performance, right? Say, for example, now I'll take one example. Say, when you do energy planning, you say, okay, I have a 500 machines. So out of 500 machines, 200 has like say 10 wattage machines, motors, and others have 15 wattage motors. So, and then their running time is like, maybe 12 hours, 6 hours. So you can do all the calculation and then maybe you can compare with your energy bills, right? So that is one way of doing it. Or maybe you can use the energy audit and identify the significant area. So there are different ways you can do so of the energy planning, right? So depend on your organization, you can do a theoretical or you can do a like practical way of energy planning part, right? So this is the one requirement of the standard. And then when you do energy planning, this is the structure we do. Like you can see planning input, energy review, planning output. So planning input mean like you study about past and present energy uses. So your past, your electricity usage for last 12 months, your solar usage for last 12 months, right? And then your diesel usage for last 12 months, your LPG gas usage for last 12 months, because it covers the entire circle, maybe on a financial year or maybe a calendar year or maybe a defined cycle, right? And then you need to study relevant variables affecting the significant end users and the performance. Say, for example, what do you mean by relevant variables? Say electricity depend on the mix, like you use solar and electricity, a kind of a mix. So if during now, like solar productivity is very high, or maybe the hydro usage is quite low. So you identify those factors. What are the relevant factors? Or maybe your machine capacity, or maybe like output of the people, or maybe if it is a garment industry, the type of garment you manufacture, right? So if like I mean that can have a kind of impact. The type of garment you use, or maybe type of people you are using, the new contract workers and all. So you need to identify all the variables. Depend on like if it's a beverage, the mix, the product mix can contribute to a lot, right? Sometimes like when you work in the beverage industry, the like when you go for a certain improvement, you at one particular point, like you can't go beyond that due to a like unless you go for a like kind of investment, right? So then what we do is like you look at the product mix. So then if you look at the product mix, then only production team cannot like control the product mix. Like, if there's a short orders, and then if you go for a continuous orders, your energy usage will be different. But then marketing team will say, look, I need this particular product. So then of course you need to go a lot of changeovers. Your energy consumption will be high, right? Maybe in beverage industry, if you are taking a bottle in, the bottle washer, it consumes a lot of energy, plus water, right? So those kind of a requirement has to be considered, right? So, and then effective factor, the product mix and all kind of a requirement we need to cover. So not only past present data, you need to identify the relevant variables, and then you analyze the energy use and consumption, right? And then identify the areas of significant energy users and then consumption. Say now in garment factory, we know like, okay, one is machine area and the operation area, other is a compressor area. So these are the two key energy users. And then of course, canteen automatically it will become significant because that's the only place they use LPG, right? So those are the key areas, right? Identify opportunity for improvement, energy performance. Now, say government factory example, if I can cut down the leakage, maybe I should be able to cut down by 1 or 2%. So that's a lot if you do an annual calculation, right? 2% of your electricity bill. So that part you need to do that. This is the energy review. In second session, you are going to do a serious case study. Guys, get ready with the case study, right? I got a feedback. Let's see. Yeah, I'll answer that question. So this part, right? Opportunity improving energy performance part, and then output has to be your energy baseline, energy performance indicators, and then your objectives, KPIs, and the target and the action plan. So these are the things which we looking at the energy planning process. So this will be very comprehensive data-driven document, right? Sometimes we spend like maybe 2 to 3 days just to come up with these document, right? So energy planning you need to do very perfectly, right? So now we are not going to do energy planning process because at the second session we are going to do. And the legal requirement is very easy because we don't need to worry about any legal requirement in Sri Lanka. But right now we need to make sure we understand all the legal requirement. So let me go to one site. See, I think you should be familiar with these two sites. One is uh, Central Environment Authority site, right? So it basically gives you if you want to identify any acts or regulation, right? So all acts are here. So earlier, those days, whenever we want to get the acts or anything, I think you can see the site, right? Uh, I'm just checking to the web page. Are you able to see this?
Yes, Mr. Asta.
Yeah.
Right, thank you. So this all the acts are here, right? All the acts regulation, right? So maybe once in 3 months, once in 6 months, one of your team member has to go through and identify if there any update, new revisions are there. So normally when you go for energy management or environment management, we have a legal register, right? So we identify the legal register. So this is one side, the CE, and then Sustainable Energy Authority. So it also basically give you all the information you are required. So these are the two sites maybe you can use as a kind of a reference, right? So energy management and all trainings, everything will be there. So there are some programs for the energy auditors and 18 days program. So those kind of requirements are there. So you can keep a track on this, and then whenever it's required, you can go for those standards, right? Understand from these areas. Right. Am I back on the presentation? Am I back on the presentation? Team, am I back on the presentation?
Yes, sir.
Yes, sir.
Right. Thank you. Right. So now that legal part, you can check with that. Uh, right. Now let's move on. So now when you do the energy review, right? So you can see the lot of time effort focusing on the energy review. It has to be record reviews, and then data has to be there. So your initial raw data. See, after you identify, if somebody has to cross check your raw data, even GHG, we check the raw data, right? Because if the raw data is wrong, your entire conclusion is wrong, right? And then you need to develop a methodology, what is, how do you calculate all the energy, and all methodology has to be developed. And then when you do energy review, right, basically you analyze the total energy consumption, and then idea say idea for energy review, significant energy, and then based on example, if I take example, identify the facility, equipment, system, process, and personnel working for on behalf of the organization that significantly affect energy use and consumption. Identify other relevant variables affecting significant energy users. Determine the current energy performance of the facility and equipment, system, and process, and identify significant energy users. The typical example, even if you take a home, right? So now, say, if you are not very much familiar with the industry, maybe if you consider your home, you have CB electricity, or maybe you have a wood, biomass or wood, or maybe LPG, right? So there are three sources of energy you'll be using. So then if you consider the electricity, what would be the significant energy users in your home? right? Maybe you can identify your living room. You have a TV and all kind of thing, fans and all. Or maybe your kitchen, you have a, like, electric hot plate, whatever, and the fridge. So if you identify, if you do an analysis, yeah, you identify maybe my kitchen would be the most significant electricity usage. And out of that, maybe fridge, maybe hot plate, maybe like, or maybe iron. So that can be part of it. So once you identify the significant energy uses, then only you can take action, right? Yeah, water kettle and water pumps. Yeah, water pumps and all. So if it is automatic, then there will be issue. So when you do analysis, like, you can even you can trial out at your home. You check all the wattages, like, in your all equipment, they have given the wattage, right? Then you roughly you have an idea about the hours, number of hours is running. Say TV, this will run these hours. The hot plate run these hours. The what do you call the motor run these hours. The iron will run these hours. So then you can do a like theoretical calculation. What into hours? What hours? Or kilowatt hours, right? So then you identify in your home, taking all the electrical equipment, what would be the watt hours? Or maybe converting to kilowatt hours. And then come back and that particular month, right, in your electricity bill, what is the exact kilowatt hours? Not the numbers, not the rupees, the kilowatt hours. And then you can compare. So there may be sometimes there may be a deviation. So then you can consider, like, you can't change the wattage. It is given, right? You can change the hours, right? And then you identify, you try to tally, like, maximum 5 to 10% deviation. And then you identify, okay, this is my energy review for my home. So my main energy goes to the ironing, or main energy goes to like, hot plate, or like, the cooking. So then if it is iron, you may be consider, like, okay, I'll do iron daily. Okay, can I cut down, because the energy goes for the heating, right? And can I do, like, once a week ironing, right? So those kind of a mechanism, we can plan it out, right? So this is very important part, right? So same scenario you can apply into your factory. So if it is electricity, you can identify all the electric equipment, and then you can do a calculation. And then based on the calculation, I told you, like, if it is a huge factory, complex factory, if you have so many equipment, so many departments, if you try to tally with your, like, only one meter, you're having a serious trouble. But you need to have a sub-meter system, right? And then you can only compare with the sub-meter reading, but sub-meter has to be calibrated. So you can see even my presentation, I'm putting a lot of effort on the energy review. So that's where your exact data analysis will be there, because if you do a proper energy review, then of course you can convert into other areas, right? So this is the key area, right? So then you will come up with all the opportunities, and then potential source, everything will be part of the energy review. Now we are not going to do an energy review because you'll be having enough case studies with Hashan, right? Now, what do you mean by baseline? So organization shall establish an energy baseline using the information in the energy review. Consider a data period suitable for the organization. So this is very important. Consider a data period suitable for the organization. Energy use and consumption. Change in the energy performance shall be measured against the energy baseline. Adjustment to the baseline shall be made in the case of one or more following. Energy performance indicators no longer reflect organization energy use and consumption, or there have been major changes to the process, operational pattern, or energy system. According to the predetermined method, the energy baseline shall be maintained and record. See, now let me explain this part. So when you identify, like, when you do an energy review, right? So when you conduct the energy review, right? When you conduct the energy review, like, you can identify the baseline. Say, for example, your organization electricity consumption per ton, right? So you identify this is my baseline, or maybe solar usage baseline, or maybe LPG gas baseline per number of plate. You identify the baseline based on 2025 data. So you think, like, year 2025 is a representative year, but right now 2026 look like it's not going to be a representative year, because there will be so many electric failures, electric cut down, So you might need to go for alternative energy because there are areas usually using electricity, but due to this potential situation, you might go for a alternative energy, like diesel, whatever, Jenny, or you might be able to hire a generator as well. Right. So these can be a challenging situation. So you identify the representative year. Maybe your representative year, not 2025, maybe 2024. So then using that representative year, you can develop action plan, improvement plan, right? So first thing, you need to do an energy review, maybe 1 or 2 years, maybe, right? And then depend on 1 or 2 years, you identify which year is the best year you to take as a baseline. And then with the baseline, you plan out all your improvement, right? So this is the data driven process. You need to do a lot of data, you need to do a lot of calculation, right? So when you do a calculation, be careful because some units come from kilowatt hours, some units come from liters, diesel comes from liters. So I'm like, when you want to convert everything into a 1 unit, maybe you can do a proper conversion, right? Otherwise, your figures will be totally different, right? So this is one area. So now energy review, energy baseline. So once you identify the energy review and energy baseline, you can develop energy performance indicators. So this energy performance indicators appropriate for the monitoring and measurement of energy performance. So this will basically reflect how you're going to perform monitoring of the indicators. The methodology for determine and updating the energy indicators shall be recorded, and regular review energy planning indicators shall be reviewed and compared to the energy baseline as appropriate. So energy baseline has to be appropriate to the indicators, right? So there will be a performance indicator. So based on your energy review, based on your baseline, you develop performance indicators. Say, for example, now garment factories, you can develop energy performance indicators saying, okay, look, my performance indicator can be per unit or per shipment. This is the energy consumption. You monitor that. Say, for example, now your home, you say, I have 5 people, and then we cook 2 meals, 3 meals, number of plates. So the electricity goes for 1 plate is this. You monitor that. Right. Okay. Or maybe total energy consumption for 5 person is this. So we try to maintain the kilowatt hours like this. So you indicate, you develop your own indicator, right? So you plan it out. So this is very even a beverage factory, right? You can identify total energy consumption for mixing area, the bottling area, right? So all areas you can identify. You can develop your energy indicators, right? So this is one key area, and then you can set energy objectives. So energy objectives, energy targets, and energy management action plan. So organization shall establish, implement, and maintain document energy objectives target, right? So maybe department wise target you can set, for example, you can say, okay, bottling and packing area, this is my target. So if you have a washer, this is my target. Garment area, this is my target. Or maybe you can identify one indicator, say in your house, right? So when you do a energy review, energy study, you identify what is the energy consumption goes to your lighting. You say maybe 10%, 20% of my energy goes to lighting, right? So this will be different in the factory environment, right? Your light energy level may be very less, maybe 1 or 2%. Even if you go for improvement, you can't see anything. But home, it will be different. So lighting, so you say, okay, 10 to 15% my energy goes to lighting. So you set action plan, right? Okay, I'm going to you always, you say, okay, in my home, I have a incandescent light, the normal filament bulb, right? You have filament bulb. So what you do is you say, okay, in my home, what I'm going to do is I have 20 bulbs in my home, right? So each room has 2 bulbs, and then surroundings, you say, okay, I have 20 bulbs. So all filament bulb, incandescent bulb. So you develop action plan, and then you identify which room using the most number of hours, the lighting will be most number of hours. So definitely not your bedroom. So maybe you might say, so you might say, okay, this my living room and the kitchen will be the most out of lighting. The usage will be from kitchen and the living room. So you started to replace with the energy saving bulbs starting from the kitchen, starting from the living room. Say normally, like if you're using a 80-watt bulb, you convert into a 5 watt with the LED bulb, and then you are getting the same light intensity because you need to maintain the same comfort level, right? So that part you do. So that's the action plan. Then you started to cut down gradually. Like you're not going to say within the same day I'm going to replace all the 20 bulbs. No, because we don't have budget for that, right? So you plan out like every month I'll try to replace, but I'll try to replace with the most significant usage areas. So it will be living room, it will be like the kitchen. Same concept you can apply in the factory as well. So if it is a pneumatic energy, right? The air, right? So sometimes some factories, people use air to clean their self as well. So again, it's a waste. So air is not there to clean people. So you can cut down all these activities and then you identify, okay, bulk of the pneumatic goes into this department. So can I make it zero leakage in that particular department? So gradually you can plan out. So we call it action plan. I got one question. What is this? Can we identify energy usage of the section by using power and energy monitoring? Yeah, of course. You can use usage by power and energy monitoring system because see what I'm saying is like if you have a power monitoring system, that's easy down, right? So if you have a system, that's easy because automatically it will give all the information. But most of the factories right now in Sri Lanka, we don't have power energy monitoring system. Right. And I think we have somebody from facility management also. Right. So facility management team, if you have a good facility management system, which indicate all the power factors and the power usage and everything, that will be your input. So your life will be easy. Right. I'm basically considering like 80% of the organization, they don't have this technology. Right. So they need to do this by manually. Right. So if you have a system, perfect is easy. Ram, you got the answer, right? Right. Now, so this is the energy objective and energy planning part. So now we are not going to do this part as well. And then implementation. If you can remember PDCA, plan, do, check, tag. So organization, once you develop, now I think like it's very, very easy for you because the example I took, right? The home example. You identify the energy, significant energy users. Even out of the significant energy users, you identify the lighting. I'm initially going to touch the lighting and the ironing part. So this year you can plan out, right? So, and then even lighting, I'm going to replace only the kitchen as well as the living room light to a more energy saving light. So do that part. Or maybe if you think I need to, there are certain windows I'm not opening up. So let me open, get more fresh, fresh air, right? Then you can cut down the fan. Or maybe you think I have a ceiling fan. So the consumption of the ceiling fan is much greater than the pedestal fan. So you maybe convert into pedestal fan. Even when you're buying a pedestal fan, you go for more energy saving. So this will be a kind of action plan, implementation action plan. And then to do this, people has to have a certain competence, right? So the competence training and awareness is a key part of the standard. Again, this is focusing on the person working for on behalf of related to significant energy users. They need to have education, training, and skills or experience, right? Yeah, we might need to give a generic training for entire staff. Agree. Right? We might need to give a generic training for entire staff. Agree. But we need to give a significant training, special training for the significant energy users. Like say for example, boiler operator. Right? Now we are very much happy. We have a biomass boiler. Right? But do we know that the operator is skillful to control the energy in biomass? Of course, there's a legal requirement. Boiler operator has to have a legal license, right? Agreed. The person has having a legal license, but that legal license is talking about your limitation and the safety parameters. But he's not aware about the energy efficiency part, right? What type of woods you should use, right? Because depend on the type of use, the wood, depend on the type of wood mix, the energy calorific value will be different. So those training has to be there because of the significant areas. Say the compressor, the engineering team, they should know about that. And then the repairing maintenance team, they should know about. And then see, I talk we have a friend in beverage industry. So when you go for a beverage industry, the beverage mix, the changeovers, are sometimes impact your energy, right? So then maybe top management, sales, marketing team also should have a little bit of understanding about the energy factors as well, because of course they need to create to the market, right? So they would love to have so many of varieties, but you can't say like, no, whatever you want, I'll give only this particular brand, this taste. No, then of course your factory will be closed down. So this will be very, very sensitive area, right? So you need to talk to your marketing team and get their input as well, right? So this is the competence training and awareness, specifically focusing on the significant energy users. So when you do energy review, you identify what are the significant energy users, and then under that energy users, there will be a people who will capable of running these machineries. So then, of course, you identify. Say, for example, you are running a transport company, and the significant energy users will be diesel. And the way the drivers they run the machinery, that can impact your energy. So that part we need to consider, right? So then they should have a proper training on that, right? So we are not going to do that part. And then the communication, we need to communicate everything, right? So communication externally, communicate internally, and then the standard has a little bit different concept. It said the organization shall decide whether to communicate externally about its energy policy, energy management system, and energy performance, and shall document its decision. If the decision is to communicate externally, the organization shall establish and implement method for this external communication. This is a bit tricky, is it? This is bit tricky, right? Decision. So in this standard, it said 50,000 standard, it says your energy consumption, the data can be communicated or not communicated. Management has to take that particular decision. Right? If you decide, I will communicate my energy users, then you need to have a mechanism. And if you decide I'm not going to communicate my data, that is also fine. That has to be documented. Why this is tricky? Any particular reason why this standard gives this kind of a leverage? Why they have given this leverage? Why it's a decision? Like, I use a 14,000 and all uh, like, about the standard. Why, if you talk about 14,000, you say, okay, policy, if required, has to communicate. Food safety has to communicate. But this 50,000 standard basically give like, that indicator is give. Why is that? Why is that? Any particular reason? Can you think of something? Why this energy data is very crucial? Why standard give a provision to whether to disclose or not to disclose? It has to be documented. Why they have given that provision? You can think of it, anything? See, sometimes this energy data is very highly competitive. Say, for example, if I'm using X amount of kilowatt hours per garment manufacturing due to my some like methodology changes. Okay, my question is, see, this standard has given a provision saying your energy data can be a publicly available data or it can be only constrained to yourself. So if it is publicly available data, or if it is like only for yourself, you need to document this statement. If it is publicly available, you need to show a mechanism how you're going to show this information. If it is only to yourself, only you need to have take a decision. Document decision has to be there. So then that will be a highly confidential document. My question is why the energy standard goes into this level? Why they are so concerned about this data? Right, this is the energy data, right? So let me answer because we don't have much time. See, energy data, say for example, I run a factory and I have a methodology. I manufacture product using this methodology with the low energy. And then because of this low energy, I can get a low, like best margins because I'm comparing myself with other factories. So I don't want to share this information, right? So we have come across similar situation. There are a few factories we work with. We complete everything, but then even like the companies are not comfortable to even go for a certification audit after we complete all the data, everything. They said like we don't want to disclose this the data even for the other third party. Right, so we complete everything up to the certification, but we hold those project. Like we conclude the project, like say if they don't go for a certification, that's not our problem, right? But you can see this energy data information are that sensitive. Yeah, it that sensitive. So when you discuss with this information, and then there are publicly available data also, but there are some industries they are very concerned about this data. And then we had one experience in not in Sri Lanka, that is overseas project. We work in energy, and then there are within one factory there are two factories, and then these two factories run by two different nationalities, right? And then but we have to go for a one certificate. And then we had a similar situation. They don't want to give this data, they don't want to show because it highlights all the inefficiencies, right? Like per ton, what is the output? Per ton, what is the output for this factory? So it's easy to compare. Right. So this data, because it's not the statement, this is 100% data, right? But data accuracy and data privacy, right? It has to, you have to maintain both, right? So when since you are going to involve in this kind of a certification and standard, you have to be careful with this, right? Now, then these are like straightforward documented information. Whatever the documents in ISO related documents, you need to basically maintain all document control, header, footer, and everything. I believe Hashan and Mr. Pushpika, they will basically share this information when they work on the documentation part, right? So this is and then control of document. So imagine you work on a Excel sheet, right? So you have a lot of data. Somebody accidentally delete one element. Do you have any experience like that? Do you have any experience like that? Yeah, so you might have experience like that, right? So if you have experience like that, right, what happened? Your entire figures are wrong, right? So the data protection, document control, where you keep this information is very important because once you do the 50,000, the finance team will of course evaluate, right? In your document, you can say, okay, I'll get 5% saving, but then finance team will say, no, look, there's no saving from electricity bills. So you need to have proper data, right? So the document control has to be there, and then operation control. See, when you do a significant identification of your energy, right? You identify these are the significant areas, say pneumatic. So then you identify what is the control for pneumatic, what is the control for boiler, what is the control of light, even in your home. You say, okay, I will one is engineering control. You try to replace all bulbs, the incandescent or the filament bulbs with the LED bulbs, right? So you have a 1 year or 6 month action plan, right? And then you will say, okay, outside bulb, we will light only after 7 p.m. And then by 9 we need to turn it off. So those are operational control. Maybe when you turn on the AC, you will say part of the operation control will be maximum you can go up to 25 centigrade, right? So that's the temperature. So you say, okay, 25 to 27, 26. So that you can't go beyond that, below that. So that's the kind of operation control. Maybe boiler, you will say, okay, boiler operation will be taken place like this. And then even chiller operation, like you might have a 1 or 2 chillers. So then depend on the capacity, you will plan out how you run the chiller operation. Right. Sometimes like an organization engineering team run both chillers, which you are not required, depend on the capacity. So that's why the competencies training should be given for those people who involved in that area, right? And then design. Okay, this is most important part. What do you mean by design? See, if your factory is going for a extension or new modification, then of course you need to consider the energy part. Like say, for example, now you have a factory, now you want to open up a new office. Then you need to consider the energy usage, right? You need to consider how you maintain the maximum efficiency using your energy, right? Maybe you might say, okay, during the daytime I don't need to light, right? But when you think of covering the light, right? You say, okay, I will open all my windows, the blinds and everything I'll open. But then what about the heat? Right. So then you say, okay, then of course, people will suffer from the temperature, and then you need to turn on the ACs more frequently, maybe cut down the pressure, the temperature. Right. Then you will say, okay, reflection windows. So you need to plan out this at the beginning, energy saving potential, right? So this is one area, right? So designing part you need to plan out, and then procurement. This is most important. Even I discussed this at the previously. What you can do is when you plan out your work, right? When you plan out your work, you can plan and design it, right? And then the procurement team, they should know about the energy. Right now, you might have a question like, my procurement team, procurement manager doesn't have any idea about the energy saving. Say your home example. Maybe your home procurement, like electrical equipment or energy sources, are procurement by father or mother. They don't have a technical background like you. So maybe they might get consult. I know this is challenging. Maybe they might get a consult from you. So if, for example, now you are going to replace the LED bulb. So you might say, okay, look, I need to get like 5-star plus bulb. So that technical knowledge has to be communicated with the procurement team. So there should be a statement saying, okay, not only the other procurement parameters, energy would be a reviewing parameter when you procurement energy sources, equipment with the energy sources. Say, for example, if you want to procurement a fan, right? You will say, okay, you check the motor capacity. So maybe your father, mother, they might just check the cost factors and go for a lowest. But if you check and say, okay, the lowers have a higher motor capacity, your energy consumption will go up, right? Because nowadays, next 2 months, we are going to extensively, you're going to use the fans, right? So that part, you need to say, okay, look, even though this is a cost, the initial cost is high, this will give a saving. So that part has to be there. So the procurement communication has to be the requirement in the standard, right? And then monitoring, measuring, this is checking your energy, data, KPIs, monitoring part you need to check. So this is basically a checking part. And then evaluation, we don't need to do any evaluation in Sri Lanka, but if you go out of the country, of course, there will be an evaluation. And then, of course, like other standard, ISO 50,000 has an internal audit, right? PDCA, Plan, Do, Check, Track. So you need to check using internal auditors. So this internal audit will be totally different. Why? It will be based on data. So your auditor should be capable of handling the data, right? So data analysis part, and then you conduct the non-conformities and the control of record part, and the management review finally. So you present your data into the top management. Let me go back to the first slide. This one. So it's start with energy policy. Your energy planning has to be perfect. So you come up with baseline, energy review, everything, and then you go for an implementation plan. So I took few examples taking from your few factories as well as your home, and then you need to do a checking, PDC checking part. So this checking can be monitoring, measuring, and analysis part. And then based on the monitoring, measuring, you can do a corrective preventive action, and then you can do an internal audit. So this will be a circle, right? And then even if you identify there's an energy leakage, right? Say, for example, you develop your internal system, compressor system, but you identify after that there will be a leakage. So then you can raise an internal NCs, right? So then you conduct management review, and then it's a continual. So again, you have to continually improve. Say, for example, now home, you select one project for this year, cut down your electricity consumption by maybe 2%, you replacing the bulb. That will be first project. And then second, you might say, okay, look, I have a iron which consists a lot of energy. So you maybe go for a new modified iron, and then you develop the methodology, the practices you are going to change. Say, okay, earlier everyday iron, Now I'm going to replace my iron with the new one, as well as I'm going to replace with my practice has to be we will be changing once a week. Maybe Saturday, Sunday you are doing. So then you cut down. So every year you need to show the improvements, right? So this is the requirement of the standard. So I think like, we are 11.3. I think we basically cover the detail about the standard requirement, right? So ISO 50001, 2018, my task is to cover that standard requirement. And then Mr. Hashan will take over. He will go through a like detailed case studies exercise, and then you will understand the energy review and all its requirement. Right. So if you have any question, anything, you can ask from me, or otherwise maybe you can post it. Do you have any question right now? I got some feedback. What is this? Yeah, I think Dham has sent some like indicator about the energy metering requirement MIT certificate. Uh, so this MIT certificate is not related. See, ISO 50,000 standard is a management system standard, right? When you go for a management system standard, these are like this MIT certificate. These are like equipment calibration. Like it basically like measure the equipment, and then it indicate whether the equipment is performing perfectly or is there any error factors, those kind of thing. So of course, when you go for 50,000, all the monitoring, measuring equipment has to be calibrated. So this is part of it, right? So it's not a similar certificate. This is kind of a product certificate. Yeah. So any other question? Right. If you have even question like, you can post it, like, and then let me hand over to the Shahan and Bashan is here. Like, so Mr. Hashan will join now, or like we'll have a small break and come back.
Thank you, Mr. Rasita. I think we'll start in about 10 minutes, around 11:15. We'll go for a 10-minute break, and then we'll hand it over to Mr. Hassan.
Right. Oh, thank you, Bashan.
Toyota Ace. How to analyze the income statement.
Thank you very much, Mr. Rasita, for that insightful and comprehensive session. I'm very sure all participants have a strong foundation on ISO 50001, the energy management system, and how to approach the implementation of the energy management system standard. Now, moving forward, we shift our focus to the technical and analytical aspects of Energy Performance Manager. It's my pleasure to introduce Mr. Hashan Randunu, an expert in implementing and consulting for ISO 50001, the Energy Management System Standard. He will cover the energy review methodology, identifying significant energy uses, establishing an energy baseline, developing meaningful energy performance indicators, data analysis, monitoring, and practical calculation exercises. So without further ado, it's up to you, Mr. Hashan.
Right. Thank you very much, Shehan. Can everyone see my screen? Shehan, can you see my screen?
Yeah, yes, Hashan, we can see your screen.
Okay. Okay. Good morning, all. I think now you know what are the requirements of ISO 50001 2018 standard. So after Rasita's session, now I'm going to cover the area of clause number 6.3 to clause number 6.6 and also clause number 9.1, which are clause number 6.3 to 6.6 is dedicated for energy planning. And also we need in clause number 9.1, we are going to monitor your energy performance and report your energy performance. Right. Right. I think now we all know uh, the theory and the background of ISO 50001. So in this session, so we'll start with energy baseline and energy performance indicators. I believe that you all know the definitions and you have basic understanding of these technical terms now. Right. First, the energy performance improvement model based on energy baseline and energy performance indicators. So in when you are implementing ISO 50001, you need to do an energy review, right? So when you are doing an energy review, you need to gather all energy related data, especially you need to gather data for your energy sources and also your energy loads, right? So energy sources can be electricity, furnace oil, diesel, LPG, right? There can be several energy sources. So you need to gather data for all energy sources. And then the energy loads, the areas you consume that energy, you need to gather data for those areas, which means, let's suppose in a company, you have a refrigeration area. So you need to gather data, how much electricity you consume for refrigeration per month, and how much biomass you consume for your boiler, right? So those kind of energy data you need to gather uh, when you do the energy review, right? After you gather energy data, then you need to analyze those energy data. To analyze those energy data, so we introduced the concept of energy baseline and energy performance indicators. Right. So first, what is an energy performance indicator? Energy performance indicator is actually a ruler. Ruler to what? Ruler to measure your energy performance. You can see the screen. The energy performance indicator is actually a ruler. So that ruler is used to measure your energy performance. So then, what is the energy baseline? Energy baseline. Energy baseline is basically used to compare your current energy performance, right? So the baseline should be appropriate for the purpose, which means you will be able to compare your current energy performance against the energy baseline, right? From the energy baseline, then you can set a target to improve your energy performance. So you can see in the screen. So energy, you can set an energy target to improve your energy performance. So then, when you are monitoring the current energy performance, we can evaluate our energy performance against the energy baseline and also against the set energy targets. So that's the basic concept of the energy review. So you will be able to get a good understanding when we are doing the case study related to this energy baseline and energy performance indicators, right? Then when we are setting an energy performance indicator, I already mentioned that energy performance indicator is a rule, right? So that rule, that indicator should be appropriate to the purpose, which means that energy performance indicator should indicate your energy performance. What's the meaning of that? Let's suppose you are manufacturing beer, right? You are manufacturing beer. So if you measure your energy performance, right? If you measure your energy performance, let's say if we take energy performance indicator as the energy per employee, right? If we take energy per employee as the energy performance indicator, would it be a proper or appropriate energy performance indicator to measure your energy performance? Actually, we cannot exactly say whether it is appropriate or not as of now, but in our general understanding, definitely it will not be appropriate for the purpose, right? Because the energy consumed for to manufacture beer is not depend or is not vary on number of employees, right? So then we need to identify proper energy performance indicator. Otherwise, you will not be able to measure your energy performance or report your energy performance accurately. If you cannot report your energy performance accurately, then you will not be able to highlight the projects and the improvements you have done and the money you have spent to improve your energy performance, right? So then next years, the top management will not allocate budget because you are not expressing the improvement you have gained through those projects and your activities, right? So when we are identifying a proper energy performance indicators, we need to consider the energy variables. So what are the energy variables? Energy variables are the things and factors that our energy consumption can vary depend on those energy variables. So we need to consider those energy variables when you are setting energy performance indicators. So there are several energy variables, right? The first aspect is inputs. Variables based on the quality or quantity of inputs entering the boundary. I have given an example, the milk entering a pasteurization process, right? I will explain this further. Think in in a tire manufacturing factory, right? In a tire manufacturing factory, you use two types of rubber. Let's say one is cured rubber, then the other one is uncured rubber. So if you use cured rubber as a raw material, then you do not have cure those rubber within your factory or within your boundary. But if you use uncured rubber, so you need to cure those rubber within your factory, within your boundary, before using that rubber to the manufacturing process. So now you can understand, if you use uncured rubber, your energy consumption will go high. If you use cured rubber, your energy consumption will go down, because you do not need to cure that rubber before your manufacturing process. So your energy consumption can be vary based on the raw material you are using, right? And the next one is process, variables related to activities occurring within the boundary. As an example, process temperature, residence time, building occupancy. So everyone can understand that the energy consumption definitely vary, depend on the activities we do within our boundary and the outputs. So most common energy variables we get from our outputs. It is variables related to products or results leaving the boundary. As an example, quantity of product produced. If we get the beer manufacturing as an example, so your energy consumption definitely will depend on the beer output, right? So beer output is one of your energy variables when you're manufacturing beer, right? And the last one is the environments, variables related to the external environmental conditions affecting energy use. Examples, heating degrees, cooling degrees, and relative humidity. Think you have a refrigeration facility, right? You have a refrigeration facility in your company. So you need to evaluate and analyze your energy performance in your refrigeration area. So energy performance in the refrigeration area, energy consumption in the refrigeration area definitely will depend on the environmental temperature and relative humidity, right? The environmental temperature and the relative humidity. So you need to consider those energy variables when you are setting energy performance indicator for the refrigeration area. Otherwise, you will not be able to analyze your energy performance properly, right? So the next one is purposes of energy performance indicators. So what are the purposes of energy performance indicators? The first one is understanding the energy performance of facilities, equipment, systems, or energy using processes. So we set energy performance indicators, right? We set energy performance indicators to get an understanding of our energy performance, right? Without the proper energy performance indicators, we cannot understand our energy performance. As an example, right? As an example, in a factory, you cannot get an understanding of your energy performance simply by looking at your energy, simply by looking at your electricity bill, right? You cannot get an understanding of your energy performance simply by looking at your electricity bills, because your electricity consumption can be vary depend on your production, right? So we need to set energy performance indicators to eliminate the impact of those energy variables. Right. The next one is communicating energy performance information and engaging the organization, right? So you need proper energy performance indicators to communicate energy performance information and engaging the organization, right? Sometimes we set KPIs, energy targets for several departments in the company. If you do not set proper energy performance indicators, your target can be challenged, because the respective department might say, look, we have used higher energy, but we have increased our production. So that kind of challenges and that kind of arguments might be happen if you do not set proper energy performance indicators. And tracking progress toward energy targets. So definitely you need to have proper energy performance indicators to evaluate your energy targets, and managing and controlling significant energy users. So significant energy users are the uh, significant energy users. We can identify significant energy users simply based on the energy consumption. If you consider the energy consumption only
Hello.
to identify the energy performance, hello?
වතුර බිලේ
Right. If you use the energy consumption to identify significant energy users, then the highest energy consumers can be your significant energy users. There are other several techniques and criteria we use to identify significant energy users, but if you are in the implementation phase, so the first cycle of your ISO 50001 management system, it's better if you can consider only the energy consumption to identify the significant energy users, right? So you need to set proper energy performance indicators, especially when you are managing significant energy users, right? And monitoring and measuring energy performance, and finally, evaluating and demonstrating continual improvement of your energy performance, right? Then the concept of energy baseline. I already mentioned that energy baseline, we use energy baseline to compare our current energy performance. So energy baseline should be appropriate to our purpose, right? So the energy baseline is used for comparison of energy performance. Comparison is made for monitoring energy performance and demonstrating energy performance improvement. And the following steps should be taken to establish an energy baseline. The first step is determine the specific purpose for which the energy baseline will be used. So when we are setting the energy baseline, so first we need to understand the purpose of setting an energy baseline. So we set the energy baseline to compare our current energy performance, right? The next step is determine a suitable data period. So when we are setting an energy baseline, we need to determine a suitable data period, right? So most of the organizations energy consumption, right? Most of the organizations energy consumption and production patterns, it can be very depend on the season, right? Especially when if you are Sri Lankan, when in Aurudhu season and in the Christmas season, in most organizations, their production and the energy consumption goes down, right? So there can be seasonal fluctuations, seasonal variations for the for the energy consumption. So when you are setting a baseline period, it's better if you can set a consecutive 12 months as the baseline period. So why you need to set a consecutive 12 months as the baseline period? So if you set a consecutive 12 months, then all the seasons are captured within that consecutive 12 months, right? And the next step is collect the data. So the next step is collect the data. If you want to compare your current energy performance against the energy baseline, so you need to have the data for the baseline period, right? So you need to have the data for the baseline period, right? Sometimes when we are going to implement ISO 50001 in organizations, during the first visit, we identify they do not have power analyzers, separate power analyzers for separate departments. So some organizations have only one or two power analyzers. So then they can gather data for their entire electricity consumption, right? Not for the separate departments. So the first advice we give for them is to install power analyzers logically to gather electricity data and then collect data at least for an year. So once they collect data for 12 months, then we have data for a baseline period, right? So when you are setting energy baseline, first you need to determine the purpose, then you need to determine the suitable period, and then you need to gather energy data for the determined baseline period. Right. The next step is analyze the data to develop a method of normalization. Right. I will explain the terminology of normalization later. Right. Simply, we take the meaning of the normalization. If we have energy variables, we need to eliminate the impact of the energy variables on our energy performance. So that's a simple meaning of the normalization. So if we identify the energy variables, so we need to normalize the data. Otherwise, we will not be able to set proper energy performance indicators, right? Then we need to determine and evaluate the energy baselines, right? The next one is concept of normalization. During the operation of any facility, equipment, system, or energy using process, the relevant variables routinely change. As a result, the energy performance, energy consumption, and energy efficiency appear to fluctuate. Right. That's what I earlier mentioned. So if you have energy variables, right? If you have energy variables, your energy consumption can be fluctuated depend on the variations of your energy variables, right? Right. If I say it again, if you have relevant energy variables, right? If you have relevant energy variables, your energy consumption can be fluctuated depend on the variations of the identified energy variables, right? So when we are setting energy baselines, we need to normalize energy baselines to what? To eliminate the impact of energy variables, right? The normalization is used to calculate the energy baseline to account for changes in the relevant variables. The organization should establish an energy baseline for each energy performance indicator using values of energy consumption and relevant variables during the baseline period. So I will explain this more when you are doing the case study because we need to calculate the energy data to get a better understanding of these theories, right? The next one is the energy baseline should be normalized if the organization has data indicating that certain variables significantly affect the energy performance, right? So the variables significantly affect the energy performance, then we definitely need to normalize our energy data, right? The organization should measure its actual energy consumption during the reporting period and compare it versus the expected energy consumption. Right. So these are the methods we use to normalize our energy data. So there are four methods. I will explain all four. So the first one is one relevant variable. Think you have only one relevant variable for identified area, right? You have only one relevant variable for your identified area, right? Then you can simply do a simple linear regression or non-linear regression model for energy consumption or energy efficiency, right? So you all know a linear regression model can be y equal mx plus c, right? Y equal mx plus c. So y is the energy consumption and m is the energy consumption per unit, right? So the x is the relevant energy variable and c is the base load of energy consumption or the energy that is not depend on the identified energy variable, right? So C is the base load. Either we can define Z as the energy load that is not vary depend on the identified energy variable, right? So how can we determine this equation? So how can we determine this equation using data? So you can simply use Excel, right? You can simply use Excel and you can do a linear regression right? You can run a linear regression, and you can determine the model, right? You can determine the model, and this determined model is the baseline, right? So the equation or the model we determined using a regression, right? That is the baseline, right? That is the baseline for your energy consumption, right? The next one is simple metric, right? The next one is simple metric. Think uh, uh, in your organization, if the energy consumption, right? If the energy consumption uh, in a specific case where m equals 0, right? In a specific case where m equals 0, right? Which means you do not have any energy variable, right? Which means you do not have any energy variables. So your energy consumption remain constant, right? Your energy consumption remain constant. So in those cases, you can simply use y equals c. So c is the constant energy consumption. So in that cases, you do not have any energy variable for the identified area, right? Right. A simple metric can be used as an energy performance indicator where there are no relevant variables affecting energy consumption. Whether a simple metric is appropriate or not can be established by observing a trend of energy consumption over time. This means that the daily, weekly, or monthly energy consumption varies within an acceptable range as established by the organization. If Y is not constant or within an acceptable range established by the organization, then this indicates that there can be relevant variables and normalization is required, right? So, if you do not have any relevant energy variables, or if you haven't identified any relevant variables, then you can simply analyze your data, right? You can simply analyze your data whether the energy consumption remain constant within an acceptable range, right? Within an acceptable range. If your energy consumption go beyond that acceptable range, then definitely there can be a energy variable that you haven't identified so far, right? So then again, you need to uh, do a brainstorming session to identify the energy variables, right? After identifying energy variables, you can consider those energy variables, and you need to do a normalization to identify the energy baselines, right? Right. And the next one is ratio. Right? In this specific case, C equals 0, right? C equals 0, which means there aren't any base load or there aren't any load that is not relevant, that is not varied, depend on the identified energy variable, right? If I repeat again, if we can use simple ratio, right? We can use simple ratio when there aren't any base load or there aren't any load that is not very depend on the identified energy variable. In that cases, we can use simple ratio, right, as your energy performance indicator. Right. So Y is the energy consumption here, and M is the energy consumption per unit. So we call that as specific energy consumption, SEC, right? X is the relevant energy variable. In this specific case, where the base load is 0, ratio of energy consumption per unit of relevant variable gives an appropriate energy model. This is usually known as the specific energy consumption, which means SEC, right? A ratio can be used as an energy performance indicator when there is no relevant variable affecting energy consumption and there is no base load energy consumption, right? So you can use ratio as the energy performance indicator only if you have one relevant energy variable. And also, if you don't have any energy based load or any load that is that can vary depend on the identified energy variable. So in those cases, you can use ratio as your energy performance indicator, right? I know most of the organization, right, when you are reporting your energy performance, you identify simple ratio as your energy performance indicators, right? So going forward, you can do further analysis, right? You can do further analysis to identify whether you can develop a regression model or not, right? If a regression model is needed, my advice is to go for a regression model. Then uh, you can have a better energy baseline, and you can analyze your energy performance better than having a ratio as the energy performance indicator, right? Right. The next one is multiple relevant variables. Think you have multiple variables, right? You have multiple relevant energy variables, right? So then you need to analyze whether all the variables are relevant or not, right? Think when we are considering a refrigeration area, right? When we are considering a refrigeration area, so the energy variables can be relative humidity, and cooling degree days can also be an energy variable, right? And also there can be other variable, the volume, the production volume can be another variable. So far we have identified three energy variables for refrigeration area. One is the relative humidity, the other one is cooling degree days, the last one is production volume. So for refrigeration area, those three can be energy variables. So first we need to identify whether all three variables are relevant or not. So how we are going to identify those variables are relevant or not? So simply you can run a multiple linear regression or multivariable regression, right? Once you run multiple linear regression, then there is a method, so you can eliminate certain variables depend on the p-value, right? Uh, if you are getting 90% of confident, right, then you can eliminate the variables if p-value is greater than 0.1, right? I think if there are stat guys, you can understand what I'm going to say, right? If you are not very familiar with statistics, then you might not be get a better understanding, but you can identify whether the variables are relevant or not by running a multiple linear regression model, right? So if the p-value is greater than 0.1, then you can eliminate those variables because those variables are not relevant for the energy performance for the identified area, right? So if you have multiple relevant variables, then this kind of energy baseline you can have y equals uh, the plus is mistakenly mentioned, so y equals m1x1 plus m2x2 plus mnx mnxn plus c. So c is the constant value. The c is not vary depend on any of the identified energy variables. So there can be a certain base load that is not vary depend on the identified energy variables, right? So you can have this kind of model for your energy baseline, right? Right. The last method of normalization is aggregated model, right? The last model of method of normalization is aggregated model. So first of all, I will give you an example. Once we implement ISO 50001 to a hotel, right? To a hotel, we identified that the energy consumption goes high, right? Energy consumption goes high uh, for off seasons, right? Energy consumption goes high in off seasons, right? For seasonal periods, energy consumption remains lower than the off seasons, right? Remains lower than the off season. So we did a brainstorming session with relevant department representatives. So we identified the reason for that. When local gets when local gets go to the hotel, so they tend to stay within the room, right? They tend to stay within the room. So the AC consumption is higher, so the energy consumption goes higher. But in seasonal periods, the foreign guests usually come to the hotels, and they normally do not stay in the room in the day period. So they go out during the day, and they only stay in the room only at night. So the energy consumption goes down, right? So after identifying that, we understood that we cannot use a single baseline for both seasonal periods and off-seasonal periods, right? So we defined two energy baselines for those two periods that we can take as aggregated model, right? We can take as aggregated model. If I read the information in the slide, an aggregated energy model can be calculated by combining different energy models. Condition based models are also aggregated models. In this case, different energy models are applied on either side of a threshold value of a relevant variable. Non condition based model can be expressed by formula 5 and 6. Right. So you can see in here there are two energy baselines, two regression models, right? You can use the first model, right? You can use the first model if xi greater than n, right? You can use the second model if xi lesser than n, right? This is a similar kind of example for what I mentioned. So in that hotel, we used one we use two separate energy models for both for season and off-seasonal periods. So that kind of scenarios we can address by setting two or more energy models aggregated, right? Right. So I think now I have explained the theories behind all the energy calculations you need to do. So let's see whether you can do practical energy calculations based on the given set of data. So Shehan has shared an Excel. So please download that Excel and open it. Right? Please download that Excel and open it. Right. To do this case study, right? To do this case study, uh, you can. I'm going to use Excel, but you can use any other statistical tools, right? So if you are doing this in Excel, you need to have data analysis under data, right? You can see here data analysis function is here. So if you do not have data analysis function, so you need to add in data analysis function. right? Otherwise, you will not be able to do this exercise. So if you do not have data analysis function, right? If you do not have data analysis function, please add in data analysis function, right? You can simply go to add-ins, and then you can add in data analysis. Otherwise, you will not be able to do this exercise. So take 2 minutes to open this Excel, and if you do not have data analysis function, please add data analysis function. If you have any questions, you can ask, right? Right. Tom has requested to explain these models using real-world examples, right, Dom? Now we are going to explain those models using real-world examples. So this data set, right? This data set we have taken from a sake manufacturing company, right? So these are actual data, right? These are actual data. So I will explain uh, the theory we have discussed so far using this case study. So you will be able to get a better understanding after this case study. Right. I think all are ready, right? Right. So first of all, I will explain the data set for you guys. So you have to open the raw data sheet, right? So in here, we have considered year 2024 as the baseline period, right? Year 2024 as the baseline period. So when you are determining a baseline period, that baseline period uh, should be goes parallelly, right? Should be goes parallelly to the current year, right? Should be goes parallel to the current year. So when we do ISO 50001 in 2024, right? 2023 and 2024, we cannot use the previous year as the baseline period because during the pandemic situation, most of the companies has gone beyond their production capacities. So we cannot use the previous year, I mean year 2022 or year 2023 as the baseline period. So we in those in that kind of scenarios, we have to find a more relevant baseline period to the current production pattern, right? So in this case, we have determined year 2024 as the baseline period. In here, there are there are 10, right? In here there are 10 electricity loads, right? There are 10 electricity loads. First one is the cool room, the packaging, processing, AC, compressed air, wastewater treatment, light and other, CO2, water, boiler, and the 11th one is losses, right? The 11th one is losses, right? Losses indicates the gap between the losses indicates the gap between the electricity source and the sum of the electricity loads, right? Losses indicates the gap between the electricity source and the sum of the electricity loads, right? So you can see here, right? You have data for consecutive 12 months, right? You have data for consecutive 12 months, and in the last column, you have the total, right? And then in 14th row, you have the total electricity, right? You have the total electricity, which means the electricity consumed by the organization. Electricity consumed by the organization, right? So total electricity you take into your organization. And in 15th row, you have furnace oil usage in liters. You have furnace oil usage in liters. So in this company, they use only two energy sources. The first one is the electricity. The second one is the furnace oil. So they use only two energy sources, right? In this company, they use only two energy sources. The first one is the electricity, and the second one is the furnace oil. They use furnace oil to run their steam boilers, right? They use furnace oil to run their steam boilers, right? They have two steam boilers. Only one is operating, and the other one is maintained as a backup. So both boilers run by furnace oil, right? They use steam, right? They use steam only for packaging area, right? They use steam only for packaging area, right? So other than the packaging area, the other areas consume only electricity, no thermal energy, right? Thermal energy is used only by the packaging area, right? Thermal energy is used only by the packaging area, right? You have to remember that thermal energy is used only by the packaging area. Other areas use only the electricity, right? So in 16th column, right? In 16th column, you can see we have taken energy from furnace oil in megajoule, right? Energy from furnace oil in megajoule. If you see the equation, right? If you see the equation, we have multiplied furnace oil liters from 37.3, right? We have multiplied furnace oil liters from 37.3. Why we took, why we have taken 37.3? So it is the calorific value, right? 37.3 is the calorific value. So there is a separate sheet for calorific values. So you can see there are two types of fuels. One is electricity and the other one is HFO, means furnace oil. So 37.3 is the furnace oil. The unit is megajoule per liter. Megajoule per liter. So which means if you burn 1 liter of furnace oil, right? If you burn 1 liter of furnace oil, it generates 37.3 megajoule, right? If you burn 1 liter of furnace oil, it generates 37.3 megajoule, right? Which means the calorific value of furnace oil is 37.3 megajoule per liter, right? Then the calorific value of electricity, we, are, we say this is the conversion factor, right? The conversion factor of electricity 3.6 megajoule per kilowatt hour, right? 3.6 megajoule per kilowatt hour. So if you need to uh, get megajoule, get electricity consumption from megajoule, then you need to multiply the kilowatt hour value from 3.6, right? If I go again to the raw data sheet, in the 17th row, you can see we have uh, we have calculated the energy from electricity from megajoule. So we have multiplied the kilowatt hour value from 3.6. Right. Then in 18th row, we have taken the sum of furnace oil energy and electricity energy, right? Sum of furnace oil energy and the electricity energy. So to do this, we need to have both energies in a same unit. Otherwise, we cannot uh, take sum of those energies, no? So that's why we convert both energy types to a single unit, right? Then in the 19th row, you have manufactured sucker volume in hectoliter, right? Hectoliter means 1 hectoliter is equals 400 liter, right? 1 hectoliter is equal 400 liter. So you have this data sheet, right? So you have this data sheet, right? First, uh, please. So first, please identify the total energy consumed by the several departments, right? Consumed by the several departments, which means you need to identify the total energy consumed by cool room, packaging, processing, AC, and etc. Right? For packaging only, you need to get the sum of electricity and furnace oil energy to get the total energy consumed by the packaging area. Right? Take 2 minutes. Right? Take 2 minutes and do this calculation. So you will have to get the total energy separately for each department. If you have any questions, you can ask, right? Take 2 minutes to do this calculation. Right. Once you complete the calculation, right, you can see the percentage of consumption by each area, right? You can see the percentage of consumption by each area. Then, then, then you'll have to reorder this consumption, right, for a descending order and get the cumulative sum. So you can see in the screen in my Excel sheet, I have already done that calculation, right? I have taken the percentage and the cumulative sum of percentage. So please do this calculation. To do this properly, you will have to copy and paste the total energy or the percentage you have already calculated. Right. If anyone have questions when you are doing calculations, please ask. So if you hesitate to ask, then you can simply drop a message. Right. In the presentation, right, during the presentation, I have mentioned about the significant energy users, right? About the significant energy users. So we identify the significant energy users because we need to focus, right? We need to focus on those significant energy users when we are doing energy improvements, right? We need to focus on the significant energy users when we are doing energy improvements, which means projects. When you are planning projects, we need to allocate more projects on the significant energy users. Why we need to allocate more projects on significant energy users? Because they consume most of the energy in the company. So if we do improvements for those areas, then we can get a more saving from those areas, right? We can get more saving from those areas because they consume the most, right? So during your first audit cycle, which means your first 3 year cycle of ISO 50001, it's better if you identify the significant energy users only based on the consumption, right? Only based on the consumption, right? Then after you have done improvements for those significant energy users, which mean the most energy consuming areas, right? After you have spending a lot of money, after you have done so many projects for those areas, right? Then you need to focus the other areas as well, right? Then you can change the criteria, right? Then you can change the criteria for identifying the energy for significant energy users, right? Which means rather than using the consumption only, you can add other criteria as well to identify significant energy users, right? Then you can determine significant energy users not only based on the energy consumption, right? Not only based on the energy consumption, but also you can use other criteria, right? Which means technological feasibility, right? Project availability. So you can consider those criteria as well when you're identifying significant energy users. Once you implement uh, so many projects for the significant energy users, you have identified only based on the consumption, right? In this case study, we'll identify the significant energy users only based on the consumption. So we'll identify the so we need to set the criteria no. So we'll set the criteria as right. So we'll set the criteria for significant energy users as right. The energy users that consume right. The energy users that consume more than 4,500 terajoule per month will be considered as significant energy users, right? I have set a criteria to identify the significant energy users, right? I have set a criteria to identify the significant energy users. The significant energy users are determined if the monthly consumption of the total energy by each area is greater than 4,500 terajoule per month, right? 4,500 terajoule per month, right? If the monthly consumption is more than 4,500 terajoule per month, then those areas will be identified as significant energy users. So this is the criteria for this case study, right? In this case study, the areas that consume more than 4,500 terajoule per month will be considered as significant energy users, right? Based on that criteria, right? Based on that criteria, packaging, cool room, processing, AC and compressed air are identified as significant energy users, right? Packaging, cool room, processing, AC and compressed air are identified as significant energy users based on the given criteria, right? Okay. So you have to remember that when you are doing implementation, ISO 50001 implementation, it's better if you can cover at least 90% of your total energy from the significant energy users, right? It's better if you can cover at least 90% of the total energy from significant energy users, which means you focus on the 90% of the total energy during the first 3-year cycle, right? Which means you're focusing on 90% of your total energy during the first 3 years of your energy management system, right? So now you have identified significant energy users, right? To get an idea, right? To get an idea about total energy distribution, right? To get an idea about the total energy distribution, you can generate a pie chart. Please generate a pie chart. Once you generate a pie chart, then you can identify, then you can have a better understanding of the total energy distribution in this company, right? If you can see my screen, the packaging area is the highest energy consumer, right? And then the cool room, then processing, AC, and compressed air, right? Those areas consume most of the energy of the company. Other all areas use only less than 9% of the total energy. Right. Generate a pie chart. Right. I think you will have generated a pie chart. So in a pie chart, you can see the areas that consume most of the energy in the organization. Right. Right. You can even compare the energy sources of the organization, right? You can even compare the energy sources of the organization. If you want to compare the energy sources of the organization, you can simply take the sum of the energy from each energy type, right? And you can generate a pie chart for that as well, right? You can generate a pie chart for that as well. Right. Here you can see I have already generated that graph, that pie chart. So you can see from your total energy, electricity is only 37%, right? Electricity is only 37%, and furnace oil is 63% of the total energy, right? So you have only two energy sources. One is electricity and the other one is furnace oil. So the electricity is 30%, 37%, and furnace oil is 63%, right? Okay. Right. Right. So now we are going to identify the relevant energy variables. Right. We are going to identify the relevant energy variables for total electricity consumption of the organization. I repeat again. Now we are going to identify the relevant energy variables, right? We are going to identify the relevant energy variables for total electricity consumption of the organization, right? So to do that, you need to do the brainstorming session, right? So that team shall consist with the representatives from the engineering department, right? The representatives from the production department and the other departments that consume electricity, right? The other departments that consumes electricity. So you need to have the representatives from all the departments, right? After gathering the team, you can do a brainstorming session and identify the variables that can affect the electricity consumption of the organization. Once you identify the variables, then you need to identify the variables that can be quantified, right? So the variables, if the variables cannot be quantified, then we cannot use those variables simply for the calculation. Right? There are other methods. We can use qualitative variables as well, but in these calculations, we cannot use qualitative variables for the calculation. So we need to identify the quantifiable variables, right? Once we identify the quantifiable variables, we need to gather data for those quantifiable variables for baseline period, right? Once we identify the quantifiable variables, we need to gather data for those quantifiable variables for the baseline period, right? After we had that brainstorming session, we identified that the sake volume, right? We identified that the sake volume is the only quantifiable relevant variable for total electricity consumption of the organization. I repeat again, after having a brainstorming session with the team, we identified that the sake volume is the only quantifiable variable for electricity consumption of the organization, right? Right. After that, after that, we need to check, right? After that, we need to check, right? We need to check whether the sake volume is a relevant variable or not, right? How do we determine that the sake volume is a relevant variable or not, right? Before going for a regression analysis, right? Before going for a regression analysis, you can simply draw a scatter plot, right? You can simply draw a scatter plot because you have only one variables, no, one quantifiable variable, no. So you can simply draw a scatter plot, right? Draw a scatter plot, electricity versus sake volume. Please draw a scatter plot considering the 12 months data for electricity versus sake volume. Right. If you have drawn the scatter plot, So my scatter plot looks like this, right? So my scatter plot looks like this. So in my scatter plot, you can see the R squared value. R squared value is 0.9195. R squared value is 0.9195. So by looking at this R squared value, I can say there is a clear correlation between Sake volume and the electricity. There is a clear correlation between the Sake volume and the electricity. That's why R squared value is near to 1, right? Right. You can see there aren't any outliers, right? There aren't any outliers. After you after drawing a scatter plot, if you identify an outlier, right? If you identify an outlier, right, you need to do an investigation for that, right? You need to identify, you need to understand the reasons behind that. Once you identify the reasons behind that, then you can uh, take a decision to get that data point to that include that data point to your regression analysis or not, right? You can take the decision to include or not, but before taking that decision, right, you need to investigate and identify the reasons behind this because otherwise we cannot get that decision. In some organizations, after the investigations, we identify that the electricity for construction has been drawn through that power, power analyzer for the particular month. So there can be several reasons, right? So there can be several reasons. So if the reasons are not relevant to the variables, either you can eliminate that data point or you can adjust that data point, right? If you use that data point without without an adjustment, right? So you will not be able to get a clear correlation between the electricity consumption and the variable. As a result of that, your regression model would be a weak model, right? Your regression model would be a weak model. So if you have an outlier, either you need to eliminate that outlier, or if you add that outlier uh, for regression analysis, you need to adjust that outlier considering the reasons you have identified after the investigation. Right. Luckily, we do not have any outlier for this particular data set. So we can then go for the regression analysis, right? To do the regression analysis, right? To do the regression analysis, you need to create this kind of table. So there is a separate sheet, right? There is a separate sheet in your Excel for regression. In that sheet, I have included this table. In this table, there are data for consecutive 12 months for production and the total electricity. So then you can run a regression analysis for that. So how do we run a regression analysis for that? If you are doing that in Excel, you can go to data, and in data, there is a function called data analysis. Right? If you do not have that data analysis under data, so you have to add in that data analysis. Right? If you click on data analysis, right? Data analysis tools will appear, right? So you can see there are several data analysis tools, right? There are several data analysis tools. Since we are going to do a regression, you need to select regression, right? So I selected regression. So then you need to input Y range, which means, right? Y range means energy. Y range means electricity consumption. So I will input the Y range. Hope you can see my screen. I will input the Y range. The total electricity consumption was taken as the Y range, right? Then you need to input X range. In here, we have only one variable now. So then I can simply input production volume as the X range. What if you have 2 or 3 variables, more variables? What if you have 3 or 2 variables, right? Then you can input those variables at once, right? You can input those variables at once as the X range, right? I will input production volume as the X range, right? Then you need to enable labels because I have included labels. And since we take the decision to eliminate the variable or not based on the p-value, p-value is higher than 0.1, we eliminate the variable, p-value is lesser than 0.1, we take that variable as a relevant variable. So for that, since we take 0.1 as the margin, so we need to adjust the confidence level from 95% to 90%. Right? I adjusted that confidence level for 90%. Right? So this regression either will be appear on the same sheet or you can generate a new worksheet. Right? You can generate a new worksheet. So I'm going to have this regression in the new worksheet. Then you can simply click OK, right? So now you have the summary output, right? Now you have the summary output, right? In the summary output, right? In the summary output, you can see the variable. You can see the variable in the last row, right? You can check the p-value. So the p-value is below than 0.1, right? P-value is below than 0.1, right? So we can take the decision. This is a relevant variable. Production volume is a relevant variable for total electricity consumption. Why? Because p-value is less than 0.1. And also, this is the good, strong regression model for total electricity. Why? Why the adjusted R squared value is 0.93. Adjusted R squared value is 0.93. And also, the intercept for the coefficient is 6,435. The base load or the load that is not depend on the identified variable is only 6,435. That's why the adjusted R squared value is so high. right? That's why the adjusted R squared value is so high. So now using this table, right? Now using this table, you can generate the regression model for total electricity consumption. So what would be the regression model for total electricity consumption? If I type it here, total electricity consumption from kilowatt hours equals to, what's the tech? M. So M is 11.466. M is 11.466, right? Multiplied by production volume from hectoliters, and base load is 6,435.009. 6,435.009. Right. Right. Now you can see this is the regression model. This is the regression model. Total electricity consumption equals 11.4466 multiplied by production volume plus 6,435.009. So this regression model, you can use as the electricity baseline, total electricity baseline, as the baseline for the total electricity, right? So this regression model you can use as the baseline for the total electricity. So how did I determine this regression model based on summary output? Intercept, right? Intercept, you can see here, intercept, and the gradient you can see here, right? Those are given under coefficient, right? Under coefficient, intercept you can identify, and also the gradient for production volume you can identify, right? Those two values we need to take from the summary output to generate the regression model, right? Now I think you all can understand how we generate a regression model, or how we determine a baseline when we are having only a single variable, right? If you are having multiple variables, right? If you are having multiple variables, the last table of summary output can include more rows, right? There will be a separate row for each variable, right? There will be a separate row for each variable. If you have separate row for each variables, then you can get the value for m under coefficient for each variable, and you can generate this kind of regression model, right? Right. Right. So this is the energy performance indicator, right? This is the energy performance indicator. So now we'll move on to clause number 9.1. So now we are going to report. Now we are going to report our energy performance, right? Now we are going to report our energy performance. So in the Excel, you have been given, right? There is a separate sheet for energy reporting, right? There is a separate sheet for energy reporting, right? So in that sheet, there are two tables. In the first table, the fifth row remains empty, right? The fifth row remains empty, right? In the fifth row, right? In the fifth row, you need to calculate the accepted electricity consumption, which means the baseline, right? You need to calculate the expected electricity consumption, which means the baseline, right? So these are the values for the current year. These are the values for the current year, which means for year 2025. These are the values for year 2025. So you have the values for production from hectoliters, and you have the values for actual electricity consumption from kilowatt hours, right? Then using the model you have determined, right? Using the model you have determined, you need to calculate the theoretical electricity consumption, or the expected electricity consumption for each and every month, right? For each and every month. You have to calculate the accepted electricity consumption for each and every month. So take 5 minutes to calculate the expected electricity consumption for each and every month. Use the regression model we have already determined to do that. Right. You have 5 minutes and go ahead. Please be hurry up. The time is flying. If you have questions, please ask. Don't hesitate to ask questions. You can see the equation I have used. If you need more time for these calculations, please drop a message. Then I will be able to give more time, right? Right. I think the time is enough. I believe you all have done this calculation. Right. Once you complete the calculation, right? Once you complete the calculation, then copy and paste the actual electricity consumption to the second table, right? Copy and paste the actual electricity consumption to the second table, and also copy and paste or the link the expected electricity consumption as well to the second table. We take energy baseline. So we take energy baseline, right? We take expected electricity consumption that we got from the model we have generated as the energy baseline, right? I repeat again, we take expected electricity consumption that we took from the model we have generated as the electricity baseline. So the model is the performance indicator, right? Model is the energy performance indicator. The value we get from the model is the energy baseline, right? The value we get from the model is the energy baseline, right? I will repeat again. The model we generated is the energy performance indicator, right? The value we get using the model we have generated is the energy baseline, right? Once you copy and paste this, right? Once you copy and paste this, you can have this kind of a table, right? You can have this kind of a table. So in the row F, in the row F, we have taken energy performance change. We have taken energy performance change. Right? We have taken energy performance change. You can see here. Once you copy and paste, once you fill in actual electricity consumption and energy baseline columns, the other columns will be generated automatically, right? So you have the values for each and every month, right? You have the values for each and every month, right? Minus signs, minus signs, minus signs indicates the improvements, right? Minus signs indicate the improvements, and the plus signs indicate the, which means we have used more energy than the expected one, right? If you get if you get the change as a plus, which that means we have used more than the expected energy, right? If you get the change as minus, which means you have consumed lesser energy than the baseline, right? So in the cumulative energy performance change, right? In the cumulative energy performance change, right? In the cumulative energy performance change, you can see you have saved 144,000 kilowatt hour during the year, right? 144,000 kilowatt hour during the year. You have saved that amount of electricity, right? You have saved that amount of electricity during the year. 1,400, 44,000 kilowatt hour per year. It is 0.82% of the total electricity you have consumed throughout the year, right? It is nearly 1% of the total electricity. So you have saved nearly 1% of your total electricity, which means you have saved 144,000 kilowatt hour during the year, right? So that's how we are going to present the energy performance, right? Then the top management can easily understand the energy performance, right? You have the cumulative sum, then during the year you have saved that much of energy, and it is that much of a percentage from your total energy of the total electricity consumption, right? Then please generate a graph, right? Then please generate a graph, right? Line diagram for actual electricity consumption and the baseline, right? You have to generate both two line diagrams in a single chart, right? Generate the two line diagrams in the single chart. Right. So in here, I have already generated that chart, right? I have already generated that chart. In this chart, you can identify, you can see the actual consumption and the expected value, which means the energy baseline has gone parallelly, right? Has gone parallelly. What's the reason behind this? The most important reason is our energy performance indicator, or the model we have generated, is really accurate model. And the other one is, we have consumed electricity as we expected. So there aren't any up and downs, right? There aren't any up and downs. We have consumed the electricity as exactly as we expected, right? That's why those two graphs has gone parallel, right? Now I think you have a good understanding about how to report your energy performance, right? So we have done this case study only based on the total electricity, right? Only considering the total electricity. So you will have to separate energy performance indicators at least for the identified significant energy users. I repeat again, you have to separate energy performance indicators at least for the identified significant energy users, because you need to monitor the energy performance of the significant energy users, because you do projects for the significant energy users, right? After doing projects, you have to identify, you have to analyze the energy performance. To analyze the energy performance, then definitely you need to have a ruler. That ruler is the energy performance indicator, right? So you need to set energy performance indicators at least for the significant energy users, right? So then we'll see how we going to set energy targets, right? We'll see how we need to set energy targets. In some organizations, uh, top management or from the group level, those companies receive energy targets, which means top management says you need to reduce total electricity by 4% or by 5%. So that we can take as the energy target. But we all know a target or an objective must be achievable, right? If we set unachievable energy targets or unachievable targets, right, then those targets are not realistic. even after putting on a considerable effort to achieve that targets, if the targets are not being achieved, then people will get demotivated, right? So we need to set realistic and achievable energy targets. To do that, first we need to identify the projects that we are capable of doing during the year, right? Before setting energy targets, we need to identify the projects that we are capable of doing during that year, right? So I have included another sheet for projects, energy objectives, right? I have included a separate sheet for projects, right? In that project, in that sheet, you can see we have identified 7 projects. We have identified 7 projects. So in the second column, I have mentioned the relevant area of that project, right? I have mentioned the relevant area of that project, right? All 7 projects are for electricity, right? In practical scenario, right? In practical scenario, all the projects are not commissioned in January, no, right? So we cannot commission all the projects at the beginning of the year or the financial year. So the projects can be commissioned throughout the year, right? When you are identifying the expected saving per year, you need to consider the commissioning month, right? Suppose uh, the project A, right? Uh, we take the project B, right? Project B is expected. Project B is expected to be commissioned in March, right? At the end of March. So we can get the saving from the project B from April onwards, right? We can get the saving from the project B from April onwards, right? Right. So we have the saving only for 9 months from that project, not for the entire year. Right? When you are calculating the expected saving, you need to consider that, right? Since we do not have much time left, uh, we'll consider all the projects to be commissioned before January. So we have the saving of those projects entire the year, right? So we consider the commissioning month as January, so we can have the saving for all 12 months, right? So please calculate the total saving from those 7 projects. Please do the calculation. So I have mentioned expected saving per month, right? I have mentioned expected saving per month. So you have to calculate the expected saving from all 7 projects for year. Please do the calculation. Take 2 minutes. I have already done that calculation. So Bihari. Right. So so for 1 month, uh, for 1 month, right? For 1 month, you can have the saving of 120,000 kilowatt hour per month, right? You can have the saving of 120,000 kilowatt hour per month. So if I take this for annually, you can have 1.44 million, right? 1.44 million saving per year. Right. So for year, the average electricity consumption is 17.6 million, right? Average electricity consumption is 17.6 million. Right? Your saving is 1.44 million, right? Your saving is 1.44 million, right? So you can set a target. You can set a target below than the expected saving from the project, right? You can set a target below than the expected saving from the project, which means if you target, if you target the total sum of expected saving to be saved, that will not be realistic, right? That will not be realistic. So your target should be slightly below than that, right? Your target should be slightly below than that. So in here, I have targeted the saving of 1.2 million per year, right? 1.2 million per year. So my expected saving would be 6.81%. 6.81% from the total electricity against the baseline, right? My target for electricity consumption would be a saving of 6.81% from the baseline. So for this, that's how we set a target for total electricity consumption, right? Using the same method, you can set targets for significant energy users as well as the total energy, right? For significant energy users as well as the total energy, right? That's how you set targets properly, right? If you take 6.7% 7%, 10% blindly, definitely you will not be able to achieve those targets, right? Because you set those targets blindly without analyzing the saving of your projects, right? Without analyzing the saving of your project, you set the targets, then definitely you will not be able to achieve those targets, So before setting energy targets, you need to gather projects, right? You need to gather projects and you need to analyze the saving, expected saving from those projects. When you are calculating the expected saving, right, you have to consider the commissioning month as well, right? In this case study, we take the commissioning month as January, right? But practically, commissioning month can be any year during the year, any month during the year. So you need to get the exact commissioning month, right? Then you need to do the calculation based on that, right? That's how you need to set energy targets.